All right, so let's get started on this one. We're going to be covering for our part of the review here, as I'm doing last semester's exam. Do not let this exam be the only exam you guys look at. You understand that the committee works on this thing, and there's only a finite number of mathematicians in the math department here, so ever so often we all get pulled on this committee. So if you go back to a couple of years, 3, 4, 5 years of exams, and look at the style of questions. You're looking at the style of questions and making sure you can answer them. If you do that, you will not be surprised by any questions they put on here, because they're going to ask you some theoretical questions, but the main thing is understanding the concept. And again, going back to several semesters, you can figure out, basically you're looking for a pattern on the type of questions they typically like every semester and stuff. All right. As you start this exam, all right, for my class, the exam starts at 8 o'clock. You have to be there at 7:30 in the morning. Where does my class have to be? College of Health and Human Services, room 155. One of my Calc 1 classes are going to be in there with you guys. So you're going to be intermixed between Calc 1 and Calc 2 folks in this one. So, but pretty much the rule still applies. The first thing you do, you took this exam last semester, so you're going to see it all over again. The first thing is this. You're going to get part number 1 book from me right from the beginning with a bubble sheet. You're going to have multiple choice, part number 1, no calculator. At the beginning exam, for the first hour, you are not allowed to use a calculator in this exam. But what is Calculus 2 all about? When you get Calculus 2, what are you doing? Integrating. So you know the majority of questions, even on the exam, as well as especially the multiple choice, no calculator section, is going to be on can you integrate, knowing the rules, use substitution, integration by parts, partial fractions, even some formula substitution. They'll give you a formula, and here's a problem. They're telling you use this formula to integrate by doing some kind of formula substitution type thing here. But you're going to integrate. But there's also some problems that they can ask you about. Some easy ones like easy numbers that you can integrate, like finding the work on a spring problem, or maybe the sequences and series kind of problems. You didn't use much calculator on that. So, but for the first hour, you are not allowed to use the calculator. Now, most folks finish this part of the exam in about 30 to 40 minutes or something like that. But the first part of the exam, you have up until 1 hour. From 8 o'clock until 9 o'clock, you have got to complete part 1. At 9 o'clock, everybody has to turn part 1 in, so I can make the official announcement. You can now use your calculator. And once you turn in part 1, you're going to get part 2 and part 3, but you still don't get to use the calculator until I tell you, okay, you can now use your calculator. But I'm telling you, most of the questions in this exam, you won't need a calculator for. So let's take a look at this guy. Here comes part number 1. And what a surprise. Right from the beginning, multiple choice, no calculators, and what do they want you to do? Integrate. And you're still going to have to evaluate stuff, but they're going to be nice numbers. So let's take a look at this guy. This is equal to, well, we want to integrate the integral from 1 to 2 of 2x plus 1 dx. Well, we'll integrate it. What's the integral of 2x? X squared plus, what's the integral of 1 with respect to x? X. Put a little bracket from 1 to 2. And according to the fundamental theorem of calculus, what am I going to do? Plug in top minus plug in bottom. 2 squared plus 1, that should be 2 squared plus 2, plugging in 2, minus plug in bottom, 1 squared plus 1. Well, let's see here. 2 squared is 4, plus 2 is 6, minus 1 squared is 1, plus 1 is 2. What do I get for the answer? 4. Answer's D, and we're off and running. So let me blow this guy up so you guys can see him a little better. This one, straight up, better know the formula. And you're going to see a few of these guys on there. Integral of 2 e to the u du. Well, the variable is u. What's the integral of e to the u? E to the u plus c. 2 is a constant, leave it out front. That'll be 2 e to the u plus c, which is which answer? A. But there's going to be some theory questions here. Here's a theory question. Consider the following graph. And here's my x and y axis there. There's x-axis, y-axis. Here's my function. Comes in here, does something like this. There's y equals f of x. They want you to integrate from -1 to 2 of f of x dx. When you're integrating, theoretically, what are you doing? Area under the curve. And area captured above the x-axis is positive. Area captured below the x-axis is negative. So if I'm going from -1 to 2, here's -1, over here is 2. So this is the area here and in here. This is the area captured below the x-axis, so this will be negative. This is the area captured above the x-axis. Well, how do I find my area? Well, so this is a block. It's 1 by 1, so the area is 1 square unit here. This is 1. This is a triangle, 1/2 base times height. So this is 1 by 1, and that's 1 times 1 is 1, but 1/2 base times height, so that'll be a half. And these will be negative because they're below the x-axis, so this part is -3/2. However, this is above the x-axis here, so this area would be 1/2 base times height, make a little triangle here. 1 by 1 is 1, a half of that is a half. So the total area, which is the integral from -1 to 2 of f of x dx, will be the area of the negative part, which is a -3/2, plus the area of the positive part, which is 1/2. And what is -3/2 plus 1/2? -1. So the answer to this problem is A, -1. Area under the curve. And if it's below the x-axis, it's considered negative. This is more of a geometric kind of problem. All right, number 4. Well, you got two options on this one. I want to integrate from 0 to 1 of 3x minus 1 quantity cubed dx. No calculator, so I either can clean this guy up. How would you clean this guy up? Well, I could FOIL him out 3 times, so that's kind of a pain after a while. Or I could use what method to integrate this thing? Use substitution. Number 1 technique of integration, use substitution. What would you let u equal to? Inside parentheses. 3x minus 1. Then I take du, the derivative, which is 3 dx. Move the constant to the other side. 1/3 du equals a dx. Substitute. This will be the integral of u cubed. And the dx is replaced with 1/3 constant out front du. I'm going to do the back substitution method. So integrate this guy. 1/3 is constant. What's the integral of u cubed? That is u to the 4th over 4. No plus c because I got bounds. Cleaning this up, this will be 1/12 u to the 4th. Back substitution, this is 1/12 times u, which is 3x minus 1 raised to the 4th. And I got bounds between 0 and 1. According to the fundamental theorem of calculus, I'm going to plug in top minus plug in bottom. This is equal to 1/12 times 3 times 1 minus 1 to the 4th minus 1/12 times, running out of room here, but we got it, 3 times 0 minus 1 to the 4th. Does that make sense? Well, let's crunch some numbers here. 3 times 1 is 3, minus 1 is what? 2. 2 raised to the 4th power. What's 2 times 2 times 2 times 2? 16. So this is 16/12. I'll clean them up later. This is 16/12 minus 3 times 0 is 0, so this goes away. I get minus 1 is -1. But -1 to the 4th power is positive 1 times 1/12 is 1/12. So I get 16/12 minus 1/12, which is equal to 15/12, which you can always reduce your fractions. This thing divides by 3. So this would be 5/4. The answer is 5/4, which is answer E. And no calculator, but the numbers, even the fractions, are relatively simple. Does that make sense? All right. Take a look at this next guy. Find the integral between 1 and 2 of x squared e cubed, e raised to the x cubed dx. What method of integration would you use on this problem? I'll blow it up so you can see a little better there. You would use what? Remember this. Your number one technique of integration is U substitution. I only use integration by parts after U substitution doesn't work and it's a product. Does that make sense? Always try U substitution first. And with U substitution, the trick is whatever I let U equal to, du has got to be in the problem. And what would you let U equal to in terms of our rules of U substitution? What does U have to be here? Exponent, x cubed. And then I take du, which is derivative, which is 3x squared dx. Move my constant to the other side. 1/3 of du equals an x squared dx. Now, this is the point where I know I'm going to either use U substitution or not. Is the du part in the problem?
Yes.
Is there an x squared dx? Yes, there is. So this is a U substitution problem, not by parts. So this is equal to the integral from 1 to 2 of e to the u, and the x squared dx gets replaced with 1/3 du. And I don't have bounds, I'm going to switch my bounds later. All right, so what's the integral of e to u du? This is 1/3 e to the u, no plus c because I have bounds, but got to back substitute first. So this is 1/3 e to the, what was u equal to? X cubed evaluated from 1 to 2. Does that make sense? Now, according to the fundamental theorem of calculus, I plug in top minus plug in bottom. 1/3 e to the 2 cubed minus 1/3 e to the 1 cubed. Well, let's see here. What is 2 cubed? 2 times 2 times 2. 8. So this is 1/3 e to the 8 minus 1/3. 1 cubed is 1. That'll be just e to the first. And what do you have in common on this thing is a third. I'm trying to get it to look like one of my answers here. So this would be 1/3, factoring it out. E to the 8th minus e to the first is just e. There's my answer, which happens to be which one of these guys? The answer is e. Does that make sense? Yes, sir. If I change my bounds, and that's fine, and you're welcome to do that too. I'm just practicing, so I back substitute, in fact, because I'm working on these integral skills. But if you want to change your bounds, you at this point, once you decide to let U substitution, you would change your bounds by letting x be equal to 1, plugging it in here. So this, or you could have integrated it from x is 1. 1 cubed is still 1. But when x is 2, what's 2 cubed? 8. You could have changed the bounds and then just integrated e to the u du with a 1/3 out front, and then integrate it, plug in top, plug in bottom. You'll still get the same answer. And this would have been changing a bound. Change bounds. If you wanted to do that, that would have been perfectly fine. All right. What about number 6 here? Number 6. That's a different kind of question. What is the integral of x times e to the 3x? Remember, this is calculus 2. Everything is pretty much memorization in this class. And you've seen this problem before. Number 1, if I did U substitution on this problem, I would have to do the same trick again, which is let U equal to the exponent, which is, in this case, 3x. The du equals 3 dx, so the dx gets replaced with 1/3 du. There's e to the u, but there's an extra x left over. And if I back substitute and substitute that, that'll be like u divided by 3. It becomes 1/3 u e to the u du. It basically becomes the same problem all over again. The goal is I need to get rid of that x. My point is this. What I'm doing right now is a mental u substitution. And when I let u equal to the standard stuff, du is not in the problem. Does that make sense? So therefore, here's the deal. When u substitution doesn't work, you try that first. U sub does not work. Then what am I going to use, being that it's a product? What am I going to do now? U substitution doesn't work, and it's a product. We're going to use integration by parts. What is the formula that you have memorized for integration by parts? Integral of u dv equals uv minus integral of v du. The original problem was the integral of x e to the 3x dx. What are you going to let u equal to? What are you going to let dv equal to in terms of my problem here? U always the part you want to get rid of, and in this problem you get rid of things through the derivative. I would like to let u equal x. dv would be the rest of it, which would be e to the 3x dx. Hopefully something I can integrate. Du is equal to, what's the derivative of x? 1 dx. And v, if I got dv and I need v back again, I got to integrate. Now, what is the rule? Again, the short tricks on quick integration. What is the integral of e to the 3x dx? It's that e to the kx. Just to remind you guys, the integral of e to the kx dx is 1 over k e to the kx plus c. Standard rule we have memorized, because I don't want to spend all day trying to figure out these forms. You should be able to have this one memorized. So this is going to be 1/3 e to the 3x. No plus c's, because I got to put it into my formula here. So this would be equal to, when I plug it into my formula, u times v. U times v would be 1/3 x e to the 3x minus the integral of v, which is 1/3 e to the 3x, du, which is dx. So this integration by parts is an offsetting integral. So if you don't like to integrate this guy, then hopefully you can integrate this guy. 1/3 is a constant that goes out front. So this is 1/3 x e to the 3x minus 1/3. And what is the integral of e to the 3x dx again? Another 1/3 e to the 3x plus c. And then clean it up. I get the answer 1/3 x e to the 3x minus 1/9 e to the 3x plus c. There's my answer using integration by parts. And let's see here, which one of these guys is my answer as I look back and analyze it. It is going to be, I got to have the minus 1/9. The other one has that is, you nailed it, answer C. As I mentioned to you guys before, anytime you're doing a multiple choice test, I mean, you should be able to run the problems, no problem at all. But where most people make a careless error is they rush through getting the answers, especially in the multiple choice, because a lot of these answers look alike. There's one thing difference, a plus versus a minus and stuff like that. And if you're not paying very close attention, it's easy to grab the wrong guy when you're in a hurry. Take your time. You got 3 hours on this exam. You don't have a life. You're not going anywhere. Sit back and enjoy this thing. Take your time. All right. But if you'll notice this first part, what are we doing mostly? Integrate, 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 integrate. How do I integrate 3 times the sine of 2x dx? What method am I going to use? Use substitution. And with trig, you always want to let u equal to the angle, 2x. That would be du equals 2 dx, which makes 1/2 of du equal to dx. The 3 is a constant, pulls out front, substitution. This is the sine of u, and dx turns into a 1/2 du. Half goes out front, du. Substitution. Now, the big question is, make sure you got this memorized correctly. What is the integral of sine u? Negative cosine of u. Negative cosine of u. No bounds on this one, so plus c. And the last thing I want to do is back substitution. This will be negative 3/2 to cosine of u, which is 2x, plus c. There's my answer, which is answer, looks like E to me. Double check me on this and take your time on picking your answers, because a bunch of them are awfully close. Answer's E. Does that make sense? Questions? Look at the next guy. Blow it up a little bit. You guys can see it in the back there. Find the integral of the sine cubed t times cosine of t dt. Again, another integration. First things first. When it comes to powering up trig, that little cube right there means the sine of t is quantity cubed. This is just classic math notation, so we don't have to write extra parentheses. But if you do write the parentheses, you begin to see the problem a little better in terms of what you should actually do to this problem. What technique of integration would I use to integrate this guy? Use substitution. What would you let u equal to? Inside the parentheses. But the most important aspect of u substitution is whatever I let u equal to, du has got to be in the problem. So I would let u equal to the sine of t inside the parentheses. And that makes du, derivative of sine t is cosine of t dt. And there it is sitting in my problem. When I substitute into this guy, this is the integral of sine t was u, and we're cubing it. And the cosine of t dt gets replaced with du. What is the integral of u cubed du? U to the 4th over 4. No bounds on this one again, so plus c. And the last thing I want to do is back substitute. U was sine t, so this would be sine to the 4th t over 4 plus c. So there's my answer, which is answer, which one? Looks like answer D. They pulled the 1/4, the 4 on the bottom out front. We have covered a lot of material in Calculus 2. A lot. From Chapter 5, integrate. Chapter 6, more integrating, harder stuff. Chapter 7, physics applications. You know, volume rotation, area between two curves, work, pumping stuff out of tanks, center of mass problems, so forth and so on. Arc length, average value. We've covered so much, a lot of formulas you have to know. And wait, we got still Chapter 8 to go through. What was Chapter 8? Oh yeah, it was that great stuff called sequences and series you seem to enjoy so much. So, a lot of material, a lot of stuff to memorize. One of the beginning Chapter 5 stuff that you have memorized is something called the fundamental theorem of calculus. If you remember, there are two fundamental theorem of calculuses. The first one deals with integration. Integrate, plug in top minus plug in bottom, gives you area between two, area under the curve stuff. The other fundamental theorem of calculus, what I call part 2 fundamental theorem of calculus, was when you take the derivative of an integral, you don't go anywhere. This is one of those problems. It says this: use the fundamental theorem of calculus to find g prime of 1 if g of x is equal to the integral from 0 to x of the natural log of t to the 4th plus 2 dt. Before I can find g prime of 1, I need to find old g prime of x. In other words, I want to take the derivative of the integral from 0 to x of the natural log of t to the 4th plus 2 dt. What was the rule about taking the derivative of an integral? Fundamental theorem of calculus. They cancel each other out, and you just have a single x, which is in the top, and the constant on the bottom, but the derivative constant eventually ends up being 0. So you just plug in the top number into the original function, and that gives you what the derivative is. Derivative integral cancels, you just get the function back, natural log of x to the 4th plus 2. But that's not the answer, of course, but that is the derivative of g. Does that make sense? The derivative of an integral, fundamental theorem of calculus, that's the antiderivative, so they cancel each other out, and you plug in top. If the x was on the bottom, it would have the same answer, except it would be negative. If I have a function other than x in this thing, I would plug in whatever's on the bounds, but then I have to do chain rule times the derivative of the inside. That was that fundamental theorem of calculus stuff. But what was the question on this one? Oh yeah, we want to find g prime of 1. So now all I'm going to do is take g prime and replace all the x's with 1. This gives me the natural log of 1 to the 4th plus 2. 1 to the 4th is 1. Remember, no calculator on this section. Plus 2 is 3. So the answer to this problem is the natural log of 3, which is answer E. Does that make sense? Questions? All right, moving on. Problem number 10. Slide up to the top. You guys can see it in the back there. It says this one. The power series, the sum as n goes from 0 to infinity of negative 1 to the n, x to the 2n divided by n factorial, which is also equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, is the Maclaurin series for which expansion? Yes. I'm sorry? Zoom in. Okay. Hope you guys made a copy of this thing, but okay. There you go. Now, this is pure memorization. If you don't have it memorized, well, what you could do is actually do the Maclaurin series for each one of these things and then figure out which one it's going to be, but that's going to take you a while. This one was supposed to be free points for people who have it memorized. All right? So let's see what you guys have memorized here. Let's start with the first with one of these guys. Let's try e to the x. That was the easiest one, and we beat that to death even on your last test. What is the Maclaurin series for e to the x? 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial, yada, yada, yada. Pure memorization. What is the Maclaurin series for sine of x? Sine is what? Is that going to be odd or even? Sine is what kind of function? Odd. So what was the answer? It was x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus yada yada. It alternates, of course. Okay? And what was it for cosine? Maclaurin centered at 0, cosine of x. Cosine is an even function from the Maclaurin series perspective. So those are the even numbers, which is what? 1 minus even x squared over 2 factorial plus x to the 4th over 3 factorial minus yada yada yada. 4 factorial, thank you, that's a typo there. 4 factorial, which is exactly what they want. So what's my answer to this problem? B cosine of x. But I have a question for you. What would the power series be of the sine of x squared? Knowing the power series for the sine of x, what am I going to do? Plug in this x squared for all the x's. This will be x squared minus x squared cubed over 3 factorial plus x to the 5th, excuse me, x squared to the 5th over 5 factorial, and power to a power you multiply. And for cosine of 2x, this would be just 1 minus plugging x squared for all my x's, x squared squared over 2 factorial plus x squared to the 4th over 4 factorial, so forth and so on. So this would be 4th power, this would be 6th power, so forth and so on. But the question basically is, if you got this guy memorized, this is just 3 extra points you just made on the final exam. Does that make sense? Know your Maclaurin series on that sheet on the last thing we did. I wrote down all the ones you're expected to know, and this was one of them. All right, let's take a look at the next guy, number 11. Integrate x cosine of x dx. Well, again, if I did u substitution, I would have to let u equal to the angle on the trig. What's the angle on the trig function? X. And u substitution, what do you never let u equal to? Because it's stupid. Because you don't really change the problem. The whole goal of u substitution is to change it into a form that you have memorized, right? So therefore, u substitution is not going to work. We've done this problem 14 times in class. Surprised you don't have the answer already memorized. But let's go through it again. All right, so u substitution doesn't work, and it's a product. X times cosine of x. What method am I going to use? Integration by parts again. Integral of u dv equals uv minus the integral of v du. But in my problem, I would let u equal to, since I have the integral of x cosine of x dx, I would let u equal x, because I would like to get rid of that, and I don't get rid of trig. And then dv would be the cosine of x dx. That makes du equal to derivative of x is 1 dx. And v, the integral of dv, which is the integral of cosine of x. What's the integral of cosine of x dx? Which one? Negative sign or positive sign? Because that makes a huge difference, whether you got it memorized or not. If you got it memorized wrong, the answer up here, you're going to pick the wrong answer because it's going to be one of our choices, I guarantee it. The derivative of cosine is negative sign. Therefore, the integral of cosine is positive sign. Positive sign x. Got to have that memorized, because you know if you put negative up here, it will be one of your choices and you would have chosen wrong. All right. This will be u times v, which will be x sine of x minus the integral of v sine of x dx. This is equal to x sine of x minus, what is the integral of sine x? What's the integral of sine x? Negative cosine of x. And with that negative makes it a positive cosine of x plus c. And off the page there, sorry. And so therefore, which one of these guys is going to be my answer? And be careful. Notice right now I am pausing and asking, is it this guy, is it C, or is it A? Which one has positive and it's x sine x? Which one is it? Answer is A. But you can see if you're rushing through this thing how quick and easy it is to grab C and move on, because you saw the signs, everybody was positive, you saw a trig and you saw an X on it, that must be it, move on, and then you weren't paying attention and you got it wrong. Look at number 12. Remember I told you guys that they're going to give you integration tables on this test, but we're not going to provide you with integration tables because that's just too darn expensive. I did it one time for everybody in class and put it on the Moodle site, but this is how they're going to ask you these kind of questions on the final exam. They're going to give you the formula you're supposed to use. Here it is. Use them and tell me what the integral of this guy is. Remember, using the tables in the back of the book, integration tables, is U substitution. You just have to get the right U, or in certain cases, U squared, and start out with that guy. So, my problem is, what is the integral of the square root of 1 plus 9x squared dx? This looks like integrals of the form a squared plus u squared, right? So this is the square root of the a squared plus u squared. So this is where I start. What is u squared going to have to be equal to in this problem? The u squared is the 9x squared. That's the variable part. That also makes a squared equal to 1, which makes a equal to 1, and it makes u equal to what? If u squared is 9x squared, u squared is 9x squared, what would u have to be? 3x. But I remind you, when doing tables, it's all about u substitution. Once you have identified u, then you've got to do du. Take the derivative. What's the derivative of 3x? 3dx. And what do you do with u substitution? You move the constant to the other side. That makes 1/3 du equal to dx. Now we're going to substitute all this stuff into my formula. This becomes the integral of the square root. 1 was the a squared, so that's a squared. The 9x squared was the u squared plus u squared. And the dx turns into what? 1/3 du, 1/3 is a constant. That's what you really have to keep up with, is these numbers out front. So that's 1/3 du. dx is 1/3 du. So I put the 1/3 out front and the du in the back. And you'll notice that this is actually my formula, right? That's what they gave me. But there's a 1/3 out front. So this will be 1/3 bracket u over 2 times the square root of a squared plus u squared plus a squared divided by 2, the natural log of, I'm going to run out of room, so I'll come up the corner here, u plus the square root of a squared plus u squared, close parentheses, close bracket, plus c. Okay? Now, clean it up. This is equal to, you can write it down here. Now, you'll notice, right now I am beginning to look at my answers. Here's the trick. I'm looking at my answers. They don't have a bracket out front. Does that make sense? There's no bracket out in front of this thing with the 1/3. So they must have distributed this 1/3. This is how you're going to know what your answer is going to be. So I'm going to put 1/3. What is 1/3 times u over 2? U over 6. So I'm going to put that over 6. And what's u equal to? Let's back substitute while we're doing it. U is 3x. We'll clean them up in a minute. Times the square root of a squared, which is 1, plus u squared, which is 9x squared, plus a squared, which is 1 over 2. But I got to distribute that 1/3 throughout. So what's 1/3 times a squared over 2 is a squared over 6. So I got over 6 again. Times the natural log of u, which is 3x, plus the square root of a squared, which is 1, plus u squared, which is 9x squared, close parentheses, plus c. Let me blow it up for you guys in the back to see this. So I'm literally distributing the 1/3 and cleaning this guy up. Now, one last cleanup. Trying to go for that answer for my answers here. What is 3x divided by 6? X over 2 times the square root of 1 plus 9x squared plus 1/6 natural log of 3x plus the square root of 1 plus 9x squared plus c. There is my answer. Now, which one of these guys is my answer? I got to have x divided by 2. Which one has x divided by 2? Of course, there are two of them. It's a possibility of b or d. Which one is it? Well, the second coefficient you had to distribute, so that gave me a 1/6. So which one is my answer? The answer is D. Take your time. Does that make sense? Did you see what I did there in terms of that constant out front, in terms of my answer? They typically don't want that constant factored out. They'll distribute it throughout the formula. And when you distribute that 1/3 throughout the u over 2 and the a squared over 2, you get the u over 6 and the a squared over 6. And then you had to clean it up. U was 3x. 3x divided by 6 is x over 2. That matches this guy, and you got the plus 1/6 out front. This is my dude. Does that make sense? All right. I skipped one? Thank you. I'm sorry. I did all this work, but you're right. There's one down here. I'm sorry. I would have figured that out when I'm starting to fill in my bubble sheet here. But this one's a nice, easy one here. Let's take a look at this guy. Remember this problem. They're going to throw one of these guys at you guys on the exam as well. What is the integral from 0 to 2 of the absolute value of x minus 1 dx? Have you guys integrated absolute value before? Well, you have, but you got to remember what section it was. It was actually section 5.2 or something like that, 5.1, 5.2. Here's the deal. In terms of formulas I have memorized, I do not have the integral of the absolute value of anybody memorized. But when in doubt, remember the basic idea behind calculus. When I am integrating with bounds, what am I finding? Area under the curve. This is a geometric problem. They want you to draw a freaking picture. All right, so let's draw a picture here. What does the graph of y equals absolute value of x minus 1 look like? Well, remember what the absolute value looks like? It's the old V graph. But because I got a minus 1 inside the parentheses, remember, no calculator on this thing, so you got to know some stuff. Minus 1 means I'm going to have it shifted to the right 1 unit. So here's 1, and it's the old V graph. You remember? And when in doubt, plot points. Well, I plug in 1, I get 0. I plug in 0, I get -1, but absolute value -1 is 1. I plug in 2, I get 1, so forth and so on. So here's my graph. Now, what do they want me to do? They want me to integrate the absolute value of x minus 1 dx from 0 to 2. So what exactly am I trying to find here? I'm trying to find the area in the curve between the function and the x-axis. Perfect. Which is this part down here and this part over here. Well, I've got basically two triangles. Area of a triangle, 1/2 base times height. This is 1 by 1, which is 1. So times 1/2. So this part right here is going to be 1/2. This part over here, based upon symmetry, is 1/2. So the answer is 1/2 plus 1/2. So the answer is what? 1. Answer C. Does that make sense? They love this geometric problem where you have to use shapes like rectangles and triangles and stuff. Number 14. I ask you this. Consider the sequence. So it's a sequence problem. AN equals 2n plus 1 divided by 5n minus 1. Which of the following statements is correct? And look at the question. So this is one of those classic problems where not only do I look at the question, I have to look at the answer to see what they want me to do. What are they interested in? The word diverges, the word converges. How do I tell if a sequence converges and or diverges? What do I do to a sequence to figure out if it converges or diverges? Take the limit. All I got to do is take the limit as n approaches infinity of 2n plus 1 over 5n minus 1. Now, you can do it any which way you want to, being the degree of the top, degree of the bottom are the same. You can look at it and tell what the answer is. But personally, since this is a calculus class, I'm going to use L'Hopital's rule, because that really just screams calculus. And to do, because when I plug in infinity, I got infinity over infinity. This will be the limit as n approaches infinity of the degree of the top, which is 2, or the degree of the bottom, which is 5. The answer is 2/5. It converges to 2/5. Okay? So, which answer? E. You notice that some of these multiple choice problems are taking me 10 seconds to do. Some other ones are taking me a little bit longer to do. That's all right. You got 3 hours. You're not going anywhere. All right. Number 15. Just like the one that we've had on the test before, except for they had crappy numbers, and you got to love it because I still no calculator on this one. All right. So, there's two ways I can do this one, easy way or hard way. I'll show you the hard way first, and then I'll show you, catch a pattern. All right. They're even telling you it's a geometric series. I've got the geometric series 0.27 plus 0.0027 plus 0.00027 plus yada, yada, yada. They want me to figure out what this thing converges to, or if it diverges. Being a geometric series, we know exactly what it converges to. But remember, my formula for the standard geometric series is the sum as n goes from 1 to infinity of ar to the n minus 1. And that's equal to, it converges to a over 1 minus r if the absolute value of r is less than 1. And it diverges if the absolute value of r is greater than or equal to 1. The old geometric series. Pure memorization. But here's the deal when you have those terms written out. We've done tons of these problems. When you have terms written out, it's real easy to figure out who's A and who's R. A is always the first term from the pattern. You see a pattern here, 0.27, 0.027. If they said plus 3, 3 would not be part of the pattern. It starts with the 0.27 stuff, right? So A is your first term there. That would be 0.27. R is called the ratio. It's the number that you multiply one number by to get to the next number. What do I need to multiply by 0.27 to get 0.0027? Well, let's see here. This is tens, hundreds. This is tens, hundreds, thousand, 10,000. What do I need to multiply by hundreds to get 10,000? 1 over 100. I moved my decimal. Look, I moved the decimal place 1, 2. 2 places. That's tens, hundreds. This is 1 over 100. If I multiply this number by 1 over 100, I get this number. If I multiply this number by 1 over 100, it will move the decimal place 2 places to the left, and then I'm back to this number, 4 zeros. Then I get 6 zeros, 8 zeros, so forth and so on. Does that make sense? Now, all I got to do is plug it into my formula. Clearly, the absolute value of R, which is still 1 over 100, is less than 1, so we know it converges to, here's the deal. It is A over 1 minus R, which would be A, which is my first term of my series, 0.27, divided by 1 minus 1 over 100. But again, no calculator, so I better go fractions on this thing. What exactly is 0.27? 27 over 100. Yeah, okay. 27 over 100 divided by, what is 1 minus 1 over 100? Well, 1 is the same thing as 100 over 100, right? What's 100 minus 1? 99 over my common denominator of 100. And what do you do when you have a fraction divided by a fraction? Multiply by the reciprocal. You flip and multiply. So that's 27 over 100 times 100 over 99. The 100s cancel, and I get the answer 27 over 99. This is what it converges to. And which is answer B. Does that make sense? Geometric series, and I really didn't need a calculator for all this stuff. However, that was the long way of doing it. This is honestly a 10-second problem if you know the patterns of math. Here's the deal. I'm going to put it over here and put the word trick. I'll show you a trick on this problem. On your mark, get set, go. Add these numbers up. What do you get? 0.27, 27, 27, 27, yada, yada, yada. If I add up these numbers, this is what you get. If you ever played with your calculator, bored in a math class or whatever, when you're playing with your calculator and you get this repeating decimal, what decimals repeat? It's 0.27. It's 2 decimal places repeated, right? So it's always that number divided by 9s. It's called the power of 9s. There's 2 numbers, so I need 2 9s. 99. There's the answer right there. You don't believe me? Okay, I'm cheating right now, but remember, no calculator, but I promise you, here's the deal. 27 divided by 99, it's always the repeating decimal. Play with your calculator. Learn math. Okay? There you go. It's a problem that we did basically in the 8th grade and stuff, but okay. They wanted to do it from a, this is the calculus way of doing it, honestly, but I could have figured out the answer before I started the problem. Here's another problem. Things you are supposed to know. This is the concept of series from a mental perspective. Knowing your series formulas. Here we go. Which of the following series converges? You see this guy right here? This guy is, well, he's not harmonic, but you can compare him to a harmonic because that plus 1. This guy, by doing a limit comparison test, I would compare to this guy mentally. They're going to basically do the same thing. Now, who's this guy? What's his name? Harmonic series. And what does the harmonic series do? It diverges. Do I want this guy? No. What about this dude? Well, I have something called the divergence theorem. If I take the limit as n approaches infinity of the sequence part of my series, and I don't get 0, the divergence theorem says quickly that the series is always going to diverge. It's when when I have the sequence part converging to 0 that it may converge or may diverge. But any other than that, it's definitely going to diverge. What's the limit as n approaches infinity? What sign of infinity? What is that? That doesn't go to a number. It bounces somewhere between -1 and 1, and somewhere in the same. It doesn't go to a number. It doesn't converge. It surely doesn't go to 0. Does that make sense? Which means by the divergence theorem, divergence test, this thing does what? Diverges. I don't remind my class. Remember what I said before. The divergence theorem is a theorem or a test about a series when you're guaranteed it's going to diverge. It's going to diverge if I ever have the sequence part and the limit of that guy doesn't go to 0. So this is more of a mental thing. But you can never converge by the divergence theorem. That's stupid. Think about it. It's called the divergence theorem. It tells you about diverging things, not about converging things. So, what about this third? This guy diverges. Don't want him. What about this third dude? Well, he's not quite a peak series because of that plus 1, but you surely can compare him to a peak series by doing actually either a direct or a limit comparison test. So this would be the sum as n goes from 1 to infinity of 1 over n cubed is what this guy basically looks like. This is a p series. P is equal to what? 3, which is greater than 1, which means it does what? This guy converges. There's my winning dude right there. So understand what this means. The answer is what? Which one of these things converges? C, 3 only. And notice, no calculator, and I'm already done with this thing. And honestly, it took me about, not quite 45 minutes, a little bit less than that, because remember I got started a little bit late talking to you guys. But the fact of the matter is, it still took me about 40 minutes or so. But how long do I have on my part number 1? 1 hour. So I still got 20 minutes to sit there and go back over some stuff, just to look for those careless errors, because you know you made them on there. Go find those guys. But remember this. If you ever are doing these exams and you get down to a point where you start getting yourself confused, always go with your first instincts. You probably were correct off your first instinct when you look at one of these math problems because you've been programmed so much. Remember that. But go back, you're looking for the stupid stuff. 2 times 2, 22. Work those kind of numbers and stuff. All right. Part number 2. Now we are allowed to have the calculator. So therefore, you're going to see more of the word problem type of problems and some of the more difficult applications. But even then, I got 20 minutes before I'm allowed to use a calculator. I'm telling you, even then, quite a bit of this stuff I can do without a calculator. Let's take a look. What does this one say? The speed of a runner in feet per second increased steadily during the first 2 seconds of a race. The runner's speed at half-second intervals is given in the table. Based upon the information given, which of the following is the best upper estimate for the distance traveled during these 2 seconds? What do they want me to have? Oh, yeah. Upper estimate of the distance. And look at these guys. That is velocity. How do I go from velocity to get back to distance? You integrate. But they didn't give me a function integrate. So they gave me a table. So what am I going to use if I have a table? What's your favorite thing in chapter 5.2? Riemann sums. That's right. So I'm going to do Riemann sums. But with Riemann sums, I have two choices. With a table, you have two choices. I can either do a left Riemann sum or a right Riemann sum. They want me to have the upper estimate. Which one of these two are going to give me the upper estimate? Well, typically it's going to be the right one because my numbers are going up. I'm going from 0 to 6 to 10 to 13 to 17. My numbers are going up, so the upper estimate will be the right Riemann sum. So what's the formula for Riemann sum? Rn. That'll be the sum of your functional value times delta x. Remember your Riemann sum. And I'm going to use the right endpoint. So each one of there's an interval, here's an interval, here's an interval, here's an interval. Right Riemann sum. I've got a choice between 0 and 6. What's the point on the right? What's the bigger number? 6. So 6 times the change in x. What is my change in x for each one of these problems? They even tell you up here. What is it? 0.5 seconds. So that would be 6 times 0.5 plus between 6 to 10, the point on the right is 10. It's the y value. That would be plus 10 times delta x, 0.5. Plus between 10 and 13, the point on the right is 13. So that would be 13 times 0.5. Plus between 13 and 17, the right number is 17 times 0.5. And I could do this without a calculator if you really wanted me to, but or tell you what, if you were so concerned about the problem and getting this thing right, and I'm still in the no calculator section, I could just pause here for a second, move on to the next problem and go integrate this guy here, okay? Or do this improper integral or something like that. There's lots of problems on this thing that you don't have to have a calculator for. You can get it to a certain point and then move on until we give you the official okie dokie for using the calculator. Does that make sense? All right, but since we're doing a problem one at a time, I'll go ahead and use the calculator on this guy. That'll be 6 times 0.5 plus 10 times 0.5 plus 13 times 0.5 plus 17 times 0.5. I get 23. And don't forget, this was the velocity was feet per second, so this is your distance. It will be measured in feet, which is answer C. Does that make sense? So anytime you hear the word upper estimate, lower estimate, think right Riemann sum, left Riemann sum. And remember your web work and all the table stuff you guys did to do all those problems, and including the ones we had on our test. All right? Take a look at this next guy. Another formulas. This is why you're going back over old final exams, and as well as some old tests and whatever else you want to go over. But my recommendation is the more old final exams you can do, because I want you guys to get into the mindset of the way they're asking questions, okay? So, and also, every time you do a problem, when there's a special formula that you need, like a Riemann sum up here, or this particular problem, remember to go back and write it down on your little flashcard stuff to make sure you got the formulas memorized. Here's one. Which of the following defines the integral that gives you the length of the curve? Okay? Length of curve. Look at how they're wording it. Of y is equal to the tangent of x. This is a problem that does not require a calculator because they gave the answer as an integral. The thing you had to understand was this. What does the word length of a curve mean to you guys? That means arc length. And what is the formula for arc length? It is the integral of the square root of 1 plus the derivative squared dx from a to b. Being x is my variable on this one. I could use dy if I needed to. Does that make sense? Here's another formula you need to make sure you have memorized. Got to have that arc length thing down. And let's see if you guys remember things from Calculus 1. The integral, my bounds are between 0 and pi over 4. So that would be 0 to pi fourths. But that doesn't help me out because all my answers have 0 to pi fourths. Okay, great. Square root of 1 plus the derivative. Uh-oh, here we go. What's the tangent of x? Very good. Calculus 1 come back to haunt you. Secant squared of x, but then you're supposed to take that derivative and square him, dx. Well, one more should give it to me. The integral from 0 to pi fourths of the square root of 1 plus, what's secant of x? Secant squared of x squared. Secant to the fourth x dx, which is answer which one? Answer is B. Does that make sense? Questions? All right. Oh, here's another problem worth memorizing. This is, again, why you want to go back over several final exams, because we've covered so much material, they may miss out. This exam may miss out on a formula that maybe last fall's exam or last spring's exam did go over and stuff like that. So go over multiple exams. Don't let this be the only one you study. How do I do it? Why is this guy an improper integral? What's telling you it's an improper integral? The infinity on the bound. All right, so here we go. How do I integrate from from 2 to infinity of 1 over x minus 1 dx? Well, the first thing you want to do is make it proper. How do I make it proper? I turn this problem into, take by limit. We're all shooting for a's in this class. Limit as a approaches infinity of the integral from 2 to a of 1 over x minus 1 dx. This is equal to the limit as a approaches infinity of, what's the integral of 1 over x minus 1 dx? Now, this is what I call u substitution in your head. I don't have to write down u substitution every time when it's simple. The integral, if I did u substitution, I would let u equal to x minus 1. du is dx. So this is pretty much 1 over u. What's the integral of 1 over u? Natural log absolute value of u, which is x minus 1. You didn't have to use a column. The u substitution in your head. If you needed to write it out, don't worry, you got 3 hours. Knock yourself out. Write it down. But this is something you should be able to do in your head. With bounds from 2 to a, this is equal to the limit as a approaches infinity of the natural log of the absolute value of of a, plug in top, a minus 1 minus the natural log absolute value of 2 minus 1. Fundamental theorem of calculus. Plug in top minus plug in bottom. Well, let's clean this guy up. What's 2 minus 1? What's the natural log of the absolute value of 1? What's the natural log of 1? Things we know. 0. Don't need a calculator for that. So this is equal to the limit as a approaches infinity of the natural log of the absolute value of a minus 1. Plug in your infinity. Infinity minus 1 is infinity. So I get pretty much the natural log of infinity. What is the definition of the natural log of infinity? That is infinity. So my integral, when I integrate it, I got infinity, which tells me it does what? Diverges. In this case, diverges is going off to infinity. So my answer is D, diverges to infinity. Does that make sense? So let's go back over those things again in terms of things you are supposed to have memorized. What's e to the infinity? Infinity. What's the natural log of infinity? Infinity. What's e to the negative infinity? 0. 1 over infinity? 0. What's another one? What's the arctangent of infinity? Pi over 2. Arctangent of infinity is pi over 2. Let's see here. What's another one? What's the natural log of 0 from the plus side? Negative infinity. These are all the old limit things from even from Calculus 1 that we're expecting you guys to know about. Okay? E to the infinity is infinity. Natural log of infinity is infinity. E to the negative infinity is 0. 1 over infinity is 0. Arctangent of infinity is pi halves. Natural log of 0 from the plus side is negative infinity. And 1 over 0 from the plus side is positive infinity. 1 over 0 from the left side is negative infinity. Things we know from Calc 1. Go back, make sure you review that. All right, moving on. Number 4. Let f of x equal 1 over x. Find the Riemann sum for f on the interval between 1 and 3 using 4 subintervals of equal width, taking sample points of the right endpoints. Round your answer to 2 decimal places. Okay. What do they want me to do? Oh, yeah. Riemann sum, 4 subintervals. Okay, so make sure you got the Riemann sum form memorized. Delta x is equal to b minus a over n. My endpoints are 1 and 3, so this will be 3 minus 1, and n is the number of subintervals. That will be 4. So that's 2 over 4, which is 1/2. When I do a problem like this, I like to kind of draw it out to get an idea. Here's 1, here's 2, and here's 3 on the x-axis. I'm starting at 1, and what's my delta x equal to? 1/2. So 1, if I go over 1/2, that'll be 3/2. If I go over another 1/2, that's 2. Go over another 1/2, that's 5/2. Go over another 1/2, that's 3. And notice I got 1, 2, 3, 4 subintervals between my endpoints. We want to use right endpoints. So I'm doing a Riemann sum, a right Riemann sum for subintervals. Remember, the formula for Riemann sum is the sum of f of x times delta x. So I'm using the right endpoints for each interval here. So that would be f of 3/2 times delta x, but delta x is 1/2, using my right point. So my first one, this is on right, plus f of my next right point is in my interval is 2, f of 2 times 1/2, plus f of the next right point is 5/2, f of 5/2 times 1/2, plus, using your last endpoint, f of 3 times 1/2. Does that make sense so far? Did I lose you guys anywhere? This is why I wrote out my subintervals so I can actually see who's the dude on the right. Riemann sums, f of the function times delta x. And you remember your formula, delta x is b minus a over n. So this is equal to, now what is my function here? 1 over x. 1 over x. So if I do 1 over 3/2, 1 over a fraction does what? Where it flips the fraction, multiplied by the reciprocal. So what am I going to get? 2/3 times 1/2 plus, what is f of 2? Well, I'm plugging into 1 over x. That'll be 1 over 2, 1/2 times 1/2, plus f of 5/2, 1 over 5/2 is 2/5 times 1/2, plus x is 3, 1 over 3 times 1/2. And I don't really need a calculator for this, but I'm going to do it. You notice I have a 1/2 in common on all these guys, so I can take a 1/2 and then multiply that times. It's 2/3 plus 1/2 plus 2/5 plus 1/3. Close parentheses. Oh, and I should blow it down so you guys can see what I'm doing here. And what do I get? 0.95. Is that one of my answers? D. But I am writing this out to remind you guys of how to do Riemann sums again. But you know what? Everybody that was in my class especially, well, I made you guys do a calculator project that people hated because you had to program your calculator. But now you're going to appreciate it. Y equals, clear it out. What was my function again? 1 over x. Second quit. Clear program, Riemann sums thing, there it is. What was my A? That'll be 1, that's my low bound. What was B? 3, that's my upper bound. What was my n value? How many subintervals? 4. And I'm doing a right Riemann sum. The left was this, the right was this, the trapezoid was this guy, midpoint was this guy, and Simpson's rule. Remember the formula for writing out all this stuff, because on the free response part of the test, you're not going to get credit for doing a calculator thing without writing the function first. If they tell you to do Simpson's rule is that delta x divided by 3 times f of a plus 4 times f of x1 plus 2 times f of x2. Remember that one. The trapezoidal rule is delta x divided by trapezoidal rule. Delta x divided by 2 times f of a plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 all the way up to plus f of b. And then you got your left and right and midpoint Riemann sums. But my point is this. Yeah, okay, it's calculator time. I could use my calculator and not done any of this thing and still got it right. All right. All right, number 5. A 10-pound bag of sand is being leaked out at a constant rate of 0.5 pounds per second. as soon as it is picked up. How much work is done by a person who raises the bag from the floor to a height of 6 feet? Okay? All right. Draw it out. I got a bag here, right? Got a hole in it. Stuff leaking out of it. And then I'm going to raise it up here to 6 feet. All right. So you got to outthink this particular problem because this is not one we've done before about the bag leaking out of it. So we've got to figure this thing out. So how do I do that? Outthink the problem here. All right, the bag is going up. It is the bag is leaking out at 0.5 pounds per second. Okay? And it is being raised up at 1 feet per second. Does that make sense? So 1 feet per second and 0.5 pounds per second. But when I do work problems, what am I trying to do? Calculate work. What is the formula for work? Well, it's force times distance. It's also the integral of force dx and all this other stuff that we've done. Remember? So I got to figure out basically my change in force times my distance. So I want to basically, here's my problem right here. There's my guy. All right? And I'm lifting this bag up. So I want to figure out the work and the lift. It's force times distance. But the problem is I've got this rate in here. And you need to manipulate these rates because it's all about force and distance. Where do we ever use time in these problems? I don't. But I'm going at 1 feet per second and I got 0.5 pounds. Hey, but pounds. Hey, there's my force right there. But it's based upon seconds. I don't want it based upon seconds. What I want to do is based it upon feet. How do I do that? So this is for those chemistry students out there. This is unit analysis. Here we go. I want to convert 0.5 pounds per second to pounds per foot. How am I going to do it? Knowing the fact that I got 1 foot per second here. Well, what I'm going to do is this. I want to cancel out the seconds, right? And I want to put in feet, so the seconds cancel. Remember doing this in chemistry class? All kinds of math classes are responsible for this class. All right, so I've got feet per second here, but it's second per feet. They gave me feet per second. So to get second per feet, what am I going to do? Reciprocate it. 1 over 1 foot per second is equal to, flip your fraction, 1 second per foot. So multiply it times 1, so it's not real exciting here. But what do you end up getting here? What's 0.5 times 1? 0.5. So it's going 0.5 pounds per foot. So 0.5 pounds per foot is actually how much stuff I'm losing. Every foot that I raise it up, I'm losing 0.5 pounds. Does that make sense? All right. So it's kind of like that rope problem that we've done in class so many times. You with me? So here we go. Let's analyze a particular little piece right here. Here's my piece. I'm going to put my y-axis down here from between 0 and 6. This is my little delta y piece. And what does this little piece weigh? Well, it's 0.5 pounds per foot, and this is delta x feet that I made a little slither on. So my change in force is going to be 0.5, well, which is my delta y here, which is going to be 0.5 pounds per foot times delta y feet. So my delta force is equal to 0.5 delta y. All right? Oh yeah, what was the formula for work again? It was the integral of the change in force times distance. We used to call it distance pump when you're pumping stuff out of the tank, but this will be a distance lift. dy. Does that make sense? So this is going to end up being work is equal to the integral. What was my change in force? This thing is changing 0.5 pounds per foot. So this is 0.5 times, what is the distance I have to lift? This thing is at an arbitrary y level. How do you lift it up to the top, which is based upon my coordinate axis at 6? How am I going to do it? What's my distance here? The distance is what? You got top minus bottom, 6 minus y. Hopefully all this is coming back to you. This is just like all those work problems we've done. Times 6 minus y dy. And what are my bounds? 0 to 6, because we're lifting it the whole way. Does that make sense? Well, here we go. Now you can integrate this thing by hand, but that's fine. This is on the calculator section now, so I'm going to do my old math, number 9 function integrate, just to make sure I don't screw it up. 0.5 times 6 minus x, comma, 0, comma, 6. What do you get? I get 9. What would my units be? It's work. We're calculating work. It's either in joules, newton meters, or foot pounds. Based upon this problem, what's it going to be? Foot pounds. Because this is feet pound. It's not one of my answers. Hold on, I screwed up now. 0.5, 0 to 6. Oh, wait a minute. You are correct. I didn't read that part into it. Okay, I just got the part on lifting. This is how much work I did on just lifting and the fact that we're losing it. But wait a minute. I lost something or other here, and it's right there. I forgot the first part of it. Excuse me. I forgot about the 10-pound bag. This thing originally weighed 10 pounds, right? So this is what? What did I just calculate here? This is the work that I have lost, because this is that 0.5 is how much I'm losing, right? I am losing 0.5 pounds. Does that make sense? So I've lost 9 pounds of this thing. But what was your original formula for work? Work is equal to force times distance. Remember that? So if it was 10 pounds and if it did not have a hole in it, what would it be? Work is equal to the force, which is 10 pounds, times the distance I lifted, which is 6, which gives me 60 foot-pounds, right? But because of the hole, this is the work without the hole, and because of the hole in it, this is the work that I lost because it fell on the ground. Does that make sense? So how am I going to get this guy now? So I'm going to take the work that it took, if it didn't have a hole in it, let me slide it over here, work total would be equal to the work of the bag minus the work that we lost because of the hole in the bag. This is equal to, what was it, 60 minus the 9, which is equal to what? 51 foot-pounds. I'm sorry, I forgot that first part when I was doing this because the real integral calculus is in the second part. The answer is C, 51 foot-pounds. Does that make sense? And yes, they're going to throw problems like this at you. That we didn't do one like this during the class. Well, but yeah, we kind of did, but they threw this extra second thing is in there, so I had to manipulate my equations that I have to turn it into the variables that I need, which was foot-pounds or foot per pound or pounds per foot that I actually used and stuff. Does that make sense? All right, let's take a look at number 6. Number 6 is this. Consider the series. The sum goes from 1 to infinity of n plus 1 over 2 to the n. Which of the following results successful determination of the convergence or divergence of this series? I got a question for you. All right, straight up, look at their words that they're asking you to do. That's where a lot of people get frustrated on this exam, because it's not me making up the exam. It is a committee of mathematicians making it up, and they're trying to be as very formal sometimes as possible. Consider the series. Sum as n goes from 1 to infinity of n plus 1 over 2 to the n. Which of the following results in a successful determination of the convergence or divergence of the series? What? Look at the answers. Ratio test, divergence test, comparison with the terms 1 over 2n, comparison with the terms of the series 1 over 4 to the n, the alternating series test. They're asking you, which test should you use on this guy? Which one would you use? Why? It's based upon powers of n. Now, but granted, I could compare it to this thing, which is geometric, but it's powers of n with an n in it. Does that make sense? It's powers of n with an n. Now, if I had something like, I don't know, 1 over this guy, well, that wouldn't be the same. That would be the same thing. If I had, some other type of here we go. The sum of sine of squared of n plus 1 over 2 to the n then I would do a comparison with that guy because I want to get rid of the sine squared of 2n type of thing here because sine bounces between -1 and 1, so sine squared counts between 0 and 1. Then I would do a comparison here because you don't do ratio test on trig function stuff. But this is n's and most important powers of n's. When do I use the ratio test? When I have either powers of n's and or factorials with some extra n's thrown into it. But it's got to be powers of n and or factorials. Yes?
In a review prior that you did, I don't know if it was recently or not, there was a fraction that had factorial on the bottom. But
Yeah.
at the top you said that's absolutely.
Yeah, so there's a rule.
Yeah, is it where it's factorials only on the bottom, or is it just a factorial on the bottom?
So if I have a series where the factorials are on the bottom and I have a power of n or just n's on the top or whatever, something else, factorials are huge and they go to 0 very quickly. When the factorials are on the bottom, the series converges. When the factorials are on top, the series is going to diverge, and you can pretty much bank on that.
Situation where there's factorial on the top and the bottom.
Then they're going to cancel out. Remember, that's what we do on the ratio test. We always knock those suckers out. Then you could create to a different series. But usually it's either on the bottom or the top. It's usually not in both of them. So remember what I just said. When I have a series and the factorials are on top, and I'm going to do the ratio test on it, every time that sucker is going to diverge. When the factorials are on the bottom of my little fraction here, my series, when the factorials are on the bottom, the series is always going to converge. There's a nice little pattern for you guys on that one. All right. Number 7. Find the area of the region between. We got to find the area of the region. What am I going to do? Well, how do I find area between two curves? Integrate what? Area is equal to the integral of top minus bottom dx. Just to remember your formulas. All right, so I've got this function, x squared and y equals the sine of pi halves x. And I want to find the area between the two regions. And look, I got decimals on this thing. So to figure out this area, especially with the trig function, you're definitely going to now start wanting to use your calculator. So I want to graph this guy. So make sure you bring your graphing calculators to the exam. I don't have extra, so bring your own. I got y equals x squared, and I have the other equation is the sine of pi x divided by 2. By the way, what mode should your brain as well as your calculator be in? Otherwise, you will screw up this whole exam for every time it does a trig problem. Radians, check your mode. Good, I'm in radians. I was playing degrees earlier today. All right, so now there's my function. I'm going to do a zoom 6 on it, zoom standard, just to see what this graph looks like. There's the parabola. Here comes the old sine function, and there it is. Now, where is the area captured between these two curves? Do you see it? Well, let me help you out. Zoom in. Look again. There's the parabola. Here comes the old sine function. Do you see them now captured between these two curves? It's this little slither right here. All right? So I'm going to draw my picture. I got the parabola. I got the sine function coming in, grabbing him here, and going this way, and I'm talking about this. Can you actually see what the points of intersection are going to be? I'm going dx on this thing because I got tops and bottom. So I'm talking about this x number. What is this x number right there? It's 1. It's the first hash mark. And you can double check it because it's where they're equal to each other at. What's the sine of pi halves times 1? That's pi halves. What's the sine of pi halves? 1. What's 1 squared? 1. That's where they're equal to each other at. 0 and 1. So remember, to find the area between two curves, area is equal to the integral of the top function. What's this top function right here? Sine of pi over 2x minus, what's the bottom function right here? That is the parabola y equals what? X squared dx from my bounds from 0 to 1. This is the integral that's going to give it to me. I could integrate this thing by hand, plug in top minus plug in bottom, but at this point it's multiple choice and I'm on the calculator section of the test. By this time my hour's already way gone up to be up to this level of problems. So what I'm going to do now is, if I have to integrate with bounds that's kind of either somewhat possible for me to make a careless error, I'm definitely always going to check my answer on the calculator sections. Does that make sense? So I'm going to do math number 9. Let's see here. Sine of pi x divided by 2 minus x squared, comma x, comma low bound, which is 0, comma upper bound, which is 1, And I guess, and especially, look at these answers over here. You know you're going to get crappy decimals. Another reason why you want to use a calculator. 0.303286439. And I'm supposed to round that sucker off to, what, 2 decimal places it said? Yep, 2 decimal places. So what would my answer be? 0.30, aka the answer is E. Does that make sense? Remember, area between two curves, top minus bottom, dx, or right minus left, dy. All right, here's another one. You just saw this guy on your test. And oh, remember with the question you just asked me a few seconds ago? Here's the problem. Sum as n goes from 1 to infinity of x minus 1 to the n over n factorial. That n factorial is on the bottom. When the factorial is on the bottom, the series always converges. Always converges. So what's my answer? So it always converges for all values of x, so my answer is going to be A, negative infinity to infinity. However, that doesn't show any work, but I've got the right answer. But let me show you the work. This is a power series, right? You have a power series. Anytime they give you a power series and you want to find the interval or radius of convergence, what are you going to use? Ratio test. Let's do the ratio test on this one, just to prove it. Take the limit as n approaches infinity. This, guys, taking notes on this one. This is the ratio test. Limit as n approaches infinity, the absolute value of n plus 1 over an. This is equal to the limit as n approaches infinity of absolute value of x minus 1 to the n plus 1 over n plus 1 factorial divided by x minus 1 to the n over n factorial. When you clean this up, take your time, but this is the limit as n approaches infinity. I divide by the denominator, I flip and multiply. This is x minus 1 to the n plus 1. This flips on the bottom, x minus 1 to the n. This n factorial shows up on top. The n plus 1 factorial shows up on bottom, absolute value. What cleans up on this one? Well, I got x minus 1 to the n plus 1. Always your powers clean up. This is why you want to use a ratio test on this one. This x minus 1 to the n plus 1 is x minus 1 times x minus 1 to the n. The x minus 1 to the n's cancel. What about your factorials? Factorials always cancel with the ratio test. So n factorial by definition is n times n minus 1, yada, 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 all the way down to 1. n plus 1 factorial by definition is n plus 1 times n minus 1, all the way down to 1. What cancels on the factorials? Well, the n's cancel, the n minus 1's cancel, the dots cancel, the 1 cancel. That leaves you with what? The limit as n approaches infinity of the absolute value of what's left on top? X minus 1. And what's left on the bottom? N plus 1. But notice there is an n left over. And half the problems that we have done with this ratio test on these power series, there's just an x left over where I set it to be less than 1. Remember, ratio test. When you're less than 1, it converge. When it's greater than 1, it diverges. When it equals 1, you nuke the problem that some simple little soldier you should have done another test to. Remember, if it's equal to 1, try another test. You should never have used a ratio test on it. It wasn't a power of n or factorial, basically what we're doing. But this one has an n in it. X is a variable, but it's a variable, but it's a constant variable, so just leave them alone. But we'll look at your denominator, n plus 1. Now take a limit as n approaches infinity. Infinity plus 1 is infinity, so this is x minus 1 over infinity. And because the infinity is in the denominator, what's that equal to? 0 every time. Remember, a number divided by infinity is 0, which is always less than 1. Always less than 1 means what? My interval of convergence is for all x's. Negative infinity to infinity. Does that make sense? There's no more x's to solve for. You're always less than 1, so it works for all x's is what we're telling you. Look at the next guy. The region below the curve y equals 1 over x squared and above the x-axis between 1 and 3 is rotated. Rotated about the x-axis. Find the volume. All right, remember there are 2 forms you got to memorize on this thing. What are your 2 forms for volume rotation? Disk and washer. Volume equals pi times integral of what I call big radius squared minus little radius squared dx from A to B. This is called the disk washer method. Disk washer method, what's the big deal on this one? You use this guy when it's dx. When the function's in terms of x, I rotate around x. When the function is in terms of y, I want to rotate around y. The volume is also equal to 2 pi times integral from a to b, or what I call point radius, times f of x, top function, minus g of x, bottom function, dx. This was called the what? Shell method. With the shell method, the function is in terms of x, but you'll be rotating around the y-axis, or parallel. The function could be in terms of y, then you would be rotating around the x-axis, or parallel. Shell method rotates around the opposing axis. The disk washer method rotates around the same axis as your variable. What do we have here? We have the equation y equals 1 over x squared. 1 over x squared between 1 and 3. That looks like 1 squared is 1 whenever 1 is 1, so that's up here. 3 squared is 9, that'll be 1/9 over here, which is down there, and this is what my function looks like between the two. There's my function right there. Between the function and the x-axis right here. What do we want to rotate around? We want to rotate around the x-axis. See, we're between the function and above the x-axis that we're talking about in here, and we're going to rotate around the x-axis. My point is this. My function is in terms of x, and we're rotating around the x-axis. What method am I going to use? Disk washer. Function's in terms of x, rotating around the x, disk washer. If the function was in terms of x, and I wanted to rotate around the y-axis, I would use the shell method. Does that make sense? So this will be the disk washer method, disk washer, which would be equal to the volume equals pi times the integral of the big radius from the axis of rotation to the outside edge. That would be top minus bottom, which is 1 over x squared, that's my function, minus 0. Quantity squared minus the inside radius. When I rotate this thing, that's solid, so the little radius would be 0 squared dx from my bounds between 1 and 3. Clean it up. Volume equals pi times integral of 1 over x squared squared. That's 1 over x to the 4th dx from 1 to 3. Does that make sense? Your big radius is from the axis of rotation to the outside edge, and it's top minus bottom. This function is 1 over x squared, so that's 1 over x squared minus 0, so that's my big radius. My little radius is, well, I actually don't have a little radius because I'm not removing anything, so the little radius would be 0. Does that make sense? Now I'm going to integrate this guy, so clean him up. Well, I'll use the calculator on this one. I could do this by hand, but let's use the calculator. Math number 9 of 1 divided by x to the 4th, comma x, comma 1, comma 3. And I did that. Is that a nice fraction? It is. It is 26 over 81 pi. Oh, but they wanted a decimal answer. Well, that's just life. So, okay, I'll just take the answer and multiply times pi. And the reason why I'm using my calculator is this, 1.008412457, is because, look at those answers. They're all nice in decimals, which tells you you really want to use a calculator to do this kind of a problem. Does that make sense? Did I lose you guys anywhere on why, reminding you guys of the disk washer methods you have memorized of how to set these things up and why I use the disk washer method and what the formulas are? So which one is my answer, by the way? They wanted the 2 decimal places, so what would that be? 1.01, which the answer is D. Officially, units cubed, because you found volume. Questions? Yes, sir. All right, a couple of things. Number one, you said if it was x equals 5 or something or other, that's parallel to the y-axis. If it was x equals, y equals negative 5, that would be down here, parallel to the x-axis. Then my big radius would be top minus bottom. Y equals negative 5 is on the bottom, so that would be 1 over x squared minus 5. Minus negative 5, which would be plus 5. That would be the big radius. But then I would have a little radius, because I'm going back to the x-axis. That would be 0 minus negative 5, which would be 5. Then I would square that guy. Does that make sense? All right. All right, let's keep going here. What is the approximation obtained by the, there it is, trapezoidal rule? Okay, with the rule with n equals 2 using the approximation of the integral from 1 to 2 of x squared dx. Well, again, if you got the calculator program, this is like trivial. Let's say, for example, this was on the free response. So I'm trying not to skip any steps on you guys, is why it's taking me so long on this one. But if it doesn't, you make sure you have the trapezoidal rule formula memorized. What is the trapezoidal rule formula for n? What is my formula? It is delta x divided by 2 times f of a plus 2 times f of x1 plus 2 times f of x2, yada, 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 plus 2 times f of xn minus 1 plus f of b. That is the trapezoidal rule formula. Does that ring a bell? Good. Memorize everything. Welcome to Calc 2. All right. Delta x is the formula b minus a over n. What are my bounds on this one? My bounds, what's a and b? 1 and 2. So that would be 2 minus 1 divided by 2, which is 1/2. Now, I always draw, when I'm doing a Riemann sum, I always draw my numbers. I'm looking between 1 and 2, and my delta x is 1/2 here. So 1, move over 1/2, that would be like 3/2. And move over another 1/2 is 2. There's my 2 subintervals here. You with me? So, keep going. Now, plugging it into my formula. The trapezoidal rule for 2 is equal to 1/2 divided by 2 times f of a. That would be f of your first point, 1, plus 2 times f of your internal point, which is 3/2, plus the end point is 2, so that'll be f of 2. This is what the formula looks like, showing my work, mind you, to do this particular problem for trapezoidal rule. Does that make sense? Have I lost you anywhere? Yes?
Why is it f of 1 again?
Oh, the bounds are between 1 and 2. Remember, it's f of a. A is your endpoint and b is your endpoint. It's always f of those guys plus 2 times the internal guys. And the Simpson's rule is f of a plus 4 2 pattern. You end up on a 4 plus f of b. Okay? Now, so all I got to do now is clean this guy up. But remember, what's my function in this problem? What are we integrating? What's my function? X squared. And you'll be amazed how many people screwed this problem up by trying to do trapezoidal rule on x cubed over 3. Well, they went ahead and integrated it. Well, if you know how to integrate it, there's no real need to use trapezoidal or Simpson's rule or any of these guys. But they used it on the integral and ended up getting the wrong answer. You use it on the original function that you're trying to integrate. So let's see what we can do here. 1/2 divided by 2 is 1/4 times 1 squared. My function is x squared, so 1 squared is 1. Plus 2 times 3/2 squared is 9/4. Plus 2 squared is 4. So if I plug this, again, I could use my calculator. I'll do it by hand if you want me to, but you don't pay me enough. 1/4 times 1 plus 2 times 9/4 plus 4, close parentheses, I get the number 2.375. Which they wanted what? Let's see here. 2 decimal places, which is what? If you round this to 2 decimal places, look at the answers and be careful. You'll see another place that students screw this problem up. What's the deal? 2 decimal places is what? 2.4. The answer is C. They just couldn't round, and some people put 2.3 as the answer. But 2.375. But this is showing your work. The reason why I'm showing you the long way on how to do this problem is because if they ask this on a free response question, you have to show all this detail. But this is a multiple choice question. You show as much detail as you really want to because we're just grading your answer anyway. So based upon that, and I have and don't forget to make sure your program is nice and set with these programs on it. Y equals, my function was x squared. There it is. I'll go ahead and delete this other guy. I'll go to program, go down here to my Riemann sum. What is my a value? My a is my lower bound on my integral from my bounds. What number was that? 1. My b is 2. And what was my n, my number of subintervals? What was it? 2. And you'll notice the trapezoidal rule is 2.375, which is exactly what I got over here. Does that make sense? But you're right. If I had my calculator program, 10 seconds, I'm done. Move to the next problem. All right, another application problem here. A particle is moving along the x-axis. Its velocity at time t is 3t squared meters per second. How far does the particle travel between 0 and 2? How far does the particle travel? Be careful. They're looking for how far did the particle travel, not what the, remember, displacement versus total distance. What are they asking for in this problem? Displacement or total distance?
Total distance.
They're asking for how far does the particle travel? That's total distance. Displacement by definition is where am I relative to where I started from. So I can integrate, for example, sine of x between 0 and 2 pi. And if I integrate that, that ends up giving me 0. But does that mean that if I had a velocity that followed the path of sine of 2x, that I actually went, I didn't go anywhere? No. I went a bunch of places, but the displacement, I ended up right where I started from is basically what the displacement is. This is total distance. So the first thing you want to do with total distance is grab yourself a function. My function is 3t squared here, and graph it between 0 and 2. The nice thing about this one is they gave you a nice problem because if you graph it, you can do this by hand. Plug in 0, 1, 2. 2 squared is 4 times 3 is 12. It's a parabola. It looks like this. It's nice and positive. So I don't have any negative distance and positive distance. Does that make sense? Because it's all above the x-axis is my point. So to get this total distance traveled, all I got to do is integrate this guy. So the distance, I want to integrate the velocity, dt. This will be the integral of 3t squared dt. And my bounds are between 0 and 2. And I'm going to calculate basically this area under the curve type deal here. This will be integral of 3t squared is actually t cubed, evaluated from 0 to 2. Fundamental theorem of calculus, plug in top minus plug in bottom. That gives me 8. And don't forget, this thing was measured in meters per second, so my distance would be measured in meters. And notice, I really didn't even need a calculator for this guy. Does that make sense? However, if this function had switched from going up and been back down below the x-axis, you would have to break off the positive part above the x-axis area with the negative part, find the two different areas, make them absolute value, make everybody positive, and add them together to get total distance traveled. Does that make sense? All right. For a certain function f, it is known that f prime of x is equal to 5x to the fourth minus 2. F of 1 is equal to 4. Find f of negative 1. This is actually a Calculus 1 question at the end, but it does require Calc 2 to understand what you're doing here. They want me to know something about the function. What do I have to do to the derivative to get the original function back? Welcome to Calc 2. Yes, you're going to integrate the derivative to get the function. This would be the integral of 5x to the fourth minus 2 dx. This would be, integral would be x to the fifth minus 2x, but don't forget I'm going to have plus c. Does that make sense? So here's f of x. But to actually get what the actual function is, I got to figure out what c is. That's why they always give you this quote-unquote initial condition, setting you up for a class called differential equations here. F of 1, which would be 1 to the fifth minus 2 times 1 plus c, but f of 1 is equal to 4. 1 to the fifth is 1, 2 times 1 is 2, 1 minus 2 is negative 1, plus c equals 4. Add 1 to both sides. What does that make c equal to? 5. That makes my function f of x actually equal to x to the fifth minus 2x plus 5. That is almost my answer. But one more hurdle to jump through. What's the hurdle? What do they really want me to find in this problem? F of negative 1. This will be negative 1 to the fifth minus 2 times negative 1 plus 5. Negative 1 to the fifth power. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1. What do you got? Being an odd power, it's negative 1. Negative 2 times negative 1 is positive 2 plus 5. Minus 1 plus 2 is 1 plus 5 is 6. And the answer is E. And notice I really need a calculator for that one either. Oh, hey, Taylor series. You know Taylor and Maclaurin are coming back and hitting you in the head, so here we go. Let f of x be equal to x to the 6th. What is the coefficient of x minus 1 cubed in the Taylor expansion of f about a equals 1? Again, another formula you have to have memorized. What is the Taylor series formula? F of x is equal to f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial times x minus a cubed plus yada yada yada. Have to have this memorized just like, and what's Maclaurin series? A Maclaurin series is a Taylor series centered at 0. All right, so here we go. My function is x to the 6th, and they want my a is 1. So I got to have some derivatives here. F of x is x to the 6th. F prime would be 6x to the 5th. X double prime of x, f double prime of x would be 30x to the 4th. F triple prime of x would be what? 120 x to the third power. I could do more derivatives if I wanted to, but they're after the x minus 1 cubed. See that 3 right there? That happens to be linked to the third derivative, so that's why I stopped. Does that make sense? But these are my functions. Now I got to plug in my centering point, which is a, or which is a equals 1. So this is f of 1. 1 to the 6th power is what? 1. F prime of 1 would be 1 to the 5th is 1 times 6 is 6. F double prime of 1 would be 1 to the 4th, which is 1 times 30, which is 30. And F triple prime of 1 would be 1 cubed, which is 1 times 120, which is 120. Plugging it into my formula right here. F of x, my function would be equal to f of a, f of 1 is 1, plus f prime of a, the derivative evaluated a was what? 6. 6 over 1 factorial times x minus 1, plus f triple prime, f double prime. F double prime at a at 1 is 30. So this would be 30 over 2 factorial times x minus 1 squared, plus f triple prime of 1 at 1 at a is 1 is 120 over 3 factorial times x minus 1 cubed, plus dot dot dot. However, what is the question on this problem? The question is, what is the coefficient of this term? That term is 1 minus x cubed. Well, there it is right there. There is my 1 minus x cubed. What's the coefficient out front? The answer is right here. It's 120 over 3 factorial. 3 factorial. 3 times 2 times 1. So this is 120 over 6. See, 6 goes into 12, what? 2 times? So what's my answer? Answer's 20. Answer's B. Does that make sense? Don't lose you guys anywhere. All right. Number 14. You know this is on the test. You know you're going to be seeing this again in differential equations class, which is partial fraction expansion. And notice, they're trying to make it a multiple choice question, so they're telling you just to find the A part here. But how do I do this thing? If I want to figure out the partial fractions, I mean, they were nice enough to let me know this thing factored. So this is 7x minus 2 over x squared minus x. But that's equal to 7x minus 2 over x times x minus 1. And they broke it into, obviously, x and x minus 1. And since this is a degree 1, this has to be a degree less, which a degree less than 1 is 0, so this has got to be a constant. This is degree 1, so that's got to be a degree less, which degree 0, so that also has to be a constant. So they even set it up for me here. Now I want to figure out what a and b are. I'm going to multiply by my common denominator, which is x times x minus 1. Clear denominators, this is going to give me 7x minus 2 equals a times x minus 1 plus b. The x minus 1 cancels here, you get x. When I multiply a over x, the x is canceled, leaving me with a times x minus 1, plus b. over x minus 1 times x minus 1. The x minus 1 is canceled, leaving me with the x. So far, so good. All right. This equation, I use the annihilator method. It's the fastest and easiest method. The annihilator method basically says this works for all x's. I'm going to pick a couple of x's because I've got two letters to solve for. Pick a couple of letters. I'm going to choose a as x is 1. I'm going to choose x is 0 so I can kill off one term and then kill off the other. So you actually want me to find a, so all I really need to do is actually check x equals 0. That'll solve for a, but I'm practicing with you guys, so I will do both of them. Plug in x is 1. 7 times 1 is 7. Minus 2 is 5. Equals a times 0 plus b times 1. That goes away, and 1 times b is b, so I know the b value happens to be 5. That's not what the question was, but I'm just practicing with you guys. If I plug in x equals 0, my other annihilator, 7 times 0 is 0, minus 2 is negative 2, is equal to a times 0 minus 1 plus b times 0. Well, b times 0 goes away. That's 0 there. So, and 0 minus 1 is negative 1, so this negative 2 equals negative a. Divide by negative 1. That tells me that a is equal to 2. So the answer is B, 2. Right, you first break up your fraction. To do a partial fraction, it has to be a proper fraction, which the degree of the numerator must be less than the degree of the denominator. If it's equal to or greater than, you've got to use long division on it to break it into a true fraction part. And the second part is the denominator has to factor. And then you're breaking it over the common parts of your common denominator. You're kind of doing common denominator stuff from the 3rd grade in reverse. So instead of getting a common denominator, you're taking your big denominator and busting them back up again. All right, well, there's the second part done, and again, overly win, but we still have, we started at 2 o'clock, it's not even, it's 3:45 now. I still got officially on my exam 1 hour and 15 minutes left. Most people finish this exam in about 2 to 2.5 hours, somewhere around there. Very few people finish it less than 2 hours, unless they don't know a clue and they just turn in it blank. Or they're really, really bright. Okay, fine. But those folks are real rare. Most folks typically take 2 to 2.5 hours. Now, there's some people in here that I don't care if I give them 12 hours. I cannot get their paper out of their hands. They will hold it forever if they have a choice. Well, you do have a choice. 3 hours, I'm going home. So therefore, at 11 o'clock, I'm walking out the door because officially, pencils down, this is a timed exam type thing here. All right, we still got one more section to go here, which is the free response. Here is the big money maker right here. 40% of your exam is right here. All right, it's 60% multiple choice, the two parts, 30 each, and 40% for the free response. All right, you know something about every problem. Write something down. You are intelligent. You can figure this stuff out. Sometimes they try to give you steps on this stuff. Sometimes they just give you a problem and just let you have at it. Just write something down. Never leave anything blank. Because even then, we do grade off of partial credit. The only time you don't get partial credit is when you leave it blank and don't put anything down. All right? So, here we go. First question, with the autofocus working here, says this. Even though calculators are allowed, you must show work to receive credit. Write down everything. Don't use Riemann sum program formula. No, sorry. You actually have to write down the formulas on all this good stuff. All right. This one threw a lot of people off because, number one, it was the first problem, and they didn't know what to do because you're supposed to show a formula on this one. So a lot of people left this one blank, and it was sad because they're telling you what to do on this thing. They just want you to do it. All right, so it says this, and it's a straight problem. Use integration by parts to derive the reduction formula. They are telling you, here is the reduction formula right here. Use integration by parts. First off, they're telling me to do what? Use integration by parts. The first thing you should do is what? Write the formula down. There's some points right there. You actually got points if you wrote down the integration by parts formula. That's how many people left this one blank, just to give you a clue. So this was the integral of u dv equals uv minus the integral of v du. All right? This one was worth like 12 points or something like that. That part right there, they gave you like 2 or 3 points just for doing that. All right, so at least you understood what integration by parts meant. But now I've got this guy here. I've got the integral of the natural log of x raised to the n dx. And I want to turn it into this formula right here. So you have to analyze this part over here. And remember, you've got to, this is uv minus the integral of v du type thing is what's going on here. So this part is this part over here. All right? The deal is this. I've got to use integration by parts on this one so I can get this formula. So the trick, what we're looking for is you have to tell me what u is, and you have to tell me what dv is. And after you tell me what u is, then you got to do du. After you tell me what dv is, then you got to tell me what v is. All right. I use integration by parts when, number one, u substitution doesn't work and it's a product. Does this thing look like a product? Well, let me show you. It really is a product. 1 times. There we go. Now it's a product. And that's a standard trick. We integrated arctangent of x using the same trick in class. All right. So, what am I going to let u equal to? What am I going to let dv be? Well, if you look at this thing, it looks like I'm trying to take derivative of this guy. This idea of n, natural log of x to the n minus 1, looks like a derivative type thing here. So I want to take derivative of this guy. So I would let u equal to the natural log of x raised to the n. Because I can take derivative of that guy, and I don't know how to integrate him because that's actually the question. So it's real obvious you should let u equal to the natural log of x to the n. So therefore, the derivative, what would the derivative be? Calculus 1, chain rule. N comes out front, natural log of x raised to the what? N minus 1, but it's chain rule. Times derivative of the outside, inside stays the same, times the derivative of the inside, which is 1 over x. This is what we were looking for. dv. dv is the rest of it. Well, what are you going to let dv be? Well, that was the u part right there. So dv must be the rest, which is just the 1 dx. So you can let dv be 1 dx. And what is the integral of 1 dx? Just x. So now I'm going to write it into my formula, which again I'll remind you is u times v minus the integral of v du. And if I plug it in, u times v would be pretty much natural log of x to the n times v, which is x. I'm just like to put that guy out front. Minus the integral of v. What was v again? X times du, but du was n times natural log of x raised to the n minus 1 times 1 over x dx. And literally want to see the actual plugging in of this stuff. All right? So, but clean the second part up. This is equal to x natural log of x to the n minus, what is x times 1 over x? You always clean up your integral before you integrate it. They cancel. That leaves me with minus the integral of n times the natural log of x to the n minus 1 dx. And there is my answer. But you understand in terms of grading this particular problem, this is what we were looking for. If I'm using integration by parts, read the question again. Use integration by parts to derive. I used integration by parts by using this, and I derived the formula. Does that make sense? Questions? And again, what was bad about this test was this was the first problem on the free response. And it frustrated a lot of people because most of us, in terms of professors, we don't ask you to prove a reduction formula type thing here, but we can, but we basically just give you hard-creek formulas to use. This one, they ask you to actually prove a formula, and most people left this one blank because they didn't know what to do. And once you start leaving one problem blank, your mindset screws up, and then you end up making a 12. It's embarrassing and have to take this class again. So, you know something, write it down. What do we know? We knew integration by parts. I wrote down the formula. You got 3 points just for that. And then you just have to, from that, I have to do, there's my question right there. And they're telling you what the answer is. They should have just did this. Hey, use integration by parts on this thing. and tell me what it's equal to. Well, it'll be equal to this guy over here. And you actually got one of the answers in the back of the book. It's an integral table in the back of the book. Question? Yeah.
Joe, write the integration by parts formula in 3 points?
Well, this is a 12-point problem. If you left it blank, you got 0. If you wrote down the integration by part formula, you got 3 points out of 12. Better than 0 out of 12.
And then, like, if you did everything, but you did not write down the formula.
Oh, no, if you didn't write down the formula, well, you really needed to, because this is what you're looking for. And this is actually part of the formula. Anytime you use the integration by parts, always write down the formula. That's a pattern. Yeah?
So if you've been doing it all semester in terms of F and DG, they're not specifically looking for U and DV, right?
No, you could use F, DV. Why you want to use F and DG? God help you. I know I would never do that. But no, you can use anything you want as long as it's a version of the integration by parts formula. All right, let's go to the next one. Well, things got a little better on the next one. Here we go. Get a little confidence back after that first problem. The region bounded by the curves y equals 4x squared, x equals 1, y equals 0 is rotated about the line x equals 1 to form a solid. Yay, volume problems. Disk or washer method. The first thing you should do is to draw the picture. All right, so I'm going to draw the picture on this guy, and so I'm just going to draw him right over here. Y equals 4x squared. That's a problem. That's not hard. X equals 1. What does x equal 1 look like? Where? Because this is where people screwed it up at. At what number? X is 1. Yeah, exactly. So it's a vertical line doing this. This thing goes up. Make him a little bigger there. This is the line, x equals 1. Okay? That is a vertical line. Don't draw him horizontal because that's when you just failed the class. And then what's the other one? Y equals 0. What is the line y equals 0? Also known as? See, y equals 0, and I'll just dot him to let you know. Y equals 0 is the x-axis. All right? Okay, so have we got a region here? Yep, tops and bottoms. Here it is right here. What do we want to rotate around? We want to rotate around the line x equals 1. There's my line out there. Rotate x equals 1. But make sure you answer their question, because they're going to try to make you think on these problems to see how you apply calculus. 2. Use the disk method to set up the integral. What is the quote-unquote disk method? To set up a definite integral which gives you the volume. You do not need to evaluate the integral. Man, that's awfully nice, but we got calculators anyway. But that's awfully nice for them to do this. I just have to set up the integral. What is the disk method? Volume is equal to what? Pi times the integral from a to b of big radius squared minus little radius squared dx or dy. The disk washer method is used to, when you rotate around the x-axis or something parallel to the x-axis, the function must be in terms of x. It's x to x or y to y. What do we want to rotate around? The line x equals 1, which happens to be parallel to which axis? Y-axis. Since it's parallel to the y-axis, I want this guy to be in terms of y. I want it to be dy, because I'm going around something parallel to the y-axis. This will be from C to D there. All right. So I got to figure out what my big radius is going to be. Big radius is from the axis of rotation. Here's my axis right here to the outside edge. It's this function right here. And it's a distance. But remember, when you do tops and bottoms, it's top minus bottom gives you distance. When you do left and right dy's, it's right minus left gives you distance. So what's on the right of this distance right in here? X equals 1 minus what's on the left. Remember, it's x equals. But what was this equation right here? Y equals 4x squared, but they're supposed to have it in terms of x equals. So as y equals 4x squared, I'm going to do dy, so I have to have the function in terms of y. So I have to manipulate this equation. Solve for x on this thing. Well, I would divide by 4 equals x squared, right? Then I would take the square root of both sides, and that is going to give me the square root of y, might as well clean them up, divided by 2 equals x. Does that make sense? I solve for x in terms of y. And that's what's going to go here. The square root of y divided by 2. What would my little radius be? Well, if you think about this guy being rotated around, it's solid, right? That's why it's really the disk method. Because the disk method is there is no inside radius. It's 0 because there is no hole in this graph. This volume, it's solid. Does that make sense? There's no radius inside. So plugging it into my formula, volume would be equal to the integral of pi times integral of, what was my big radius again? It would be 1 minus the square root of y divided by 2 squared. Officially minus 0 squared. Yeah, but who cares about that? dy, but there's one thing left that I'm missing. What is that? The bounds. What are my bounds? No, it's not. Be careful. This is dy. This is what we're looking for in terms of total points. It's clearly, what's the y? This guy right here is, we're talking about y numbers. This is the x-axis, which is y equals 0. I'll give you that one. It starts at y equals 0, so that's down here. What is this point up here? How do I find that point? Well, you've got to set the equations equal to each other. It's the intersection between x is 1 and x is equal to the square root of y divided by 2, right? Set them equal to each other. 1 is equal to the square root of y divided by 2. Multiply on both sides, I get 2 equals the square root of y. And then I've got to square both sides, and what am I going to get? Y equals what? 4. The actual integral is from 0 to 4. This was the answer that they were looking for. It's got to be dy, so I have to have y numbers on the bounds. When it's dx, it's x numbers. X equals 1 is an x number. That's not a y number. Does that make sense? So I set the two equations that intersect up here equal to each other, and I got my y number. The other one is clearly y equals 0. It's right there at the x-axis. Does that make sense? Questions, complaints, comments? Okay. But now, so that did not come natural because they wanted you to manipulate the equation. Well, let's take a look at this next one. Honestly, if I gave you this problem and I said just have at it, find the volume, what method would you prefer using on this particular problem? Shell. Because the original problem, let me draw it all over again for you guys. The original problem was a parabola right here, which is y equals 4x squared. The line x equals 1 and y equals 0 gives you this region right here. The function is in terms of x. I do not like manipulating my equations. The axis of rotation is this x equals 1 rotate, right? X equals 1, which is parallel to the y-axis. When the function is in terms of x and I want to rotate around x, I want to use disk or washer method. If the function is in terms of x and I want to rotate around the y-axis or parallel, I want to use the shell method. And that's actually what they're asking you to do in this one now. They say use the method of cylindrical shells. I call that the shell method, right? What is the formula for shell method? Volume equals 2 pi times integral from a to b of what I call the point radius, times the top function f of x minus the bottom function g of x dx. Remind you that this is, the function is in terms of x, this will be rotating around the y-axis or parallel. So the volume would be equal to 2 pi times integral. What would my point radius be? You pick an arbitrary point inside your region. You're going to call that guy x. And it's the distance between the arbitrary point and the axis of rotation. The axis of rotation is x equals 1. Remember, a distance is either top minus bottom or right minus left. What's on the right? 1. What's on the left? X. So what is my point radius? 1 minus x. Times, what is the top function of my region? That's the parabola, 4x squared, minus what is the bottom function of my region? 0 dx. Now, these are x numbers. This is dx. What are my x numbers that bound the region? Clearly, you hit the origin. What was this number over here? So my bounds are 0 to 1. And they didn't tell me to integrate it. They just want me to set up the integral again. You do not need to evaluate the integral. This is my answer that they're looking for. And if you didn't put the minus 0, whoop-de-deal, you would have gotten full credit for that. It's okay. Does that make sense? They're going to hit you hard on the shell disk method. Remember that. Well, you know this problem is going to be on the test. What is this one? We got a tank and we want to pump something out of it. A tank formed by, and this one again messed a lot of people up because, and it shouldn't have, because they didn't draw you a picture, I guess. I don't know. You have to draw your own pictures on some things. So let's see if you guys can remember how to do this problem. A tank is formed by rotating about the y-axis, the region bounded by the curves, y equals x squared, x equals 0, and y equals 1. All the distances are measured in meters. The tank sits on the ground and is full of water. Find the work done in pumping all of the water out of the top of the tank. They tried to make it easier for you guys, but some people read the problem and they got frustrated, and when people get frustrated, they leave it blank. You guys are my students. You don't leave anything blank. You know something, write down what you know, write down the formula, try to go for partial credit. If you write down enough stuff, the fact is probably it'll start giving you some memory of how to do this problem, and it will fall out that you'll actually end up getting the problem correct. So here we go. First thing is they didn't give me a tank. I know it's a tank problem, but I don't know where's the tank at. Well, draw it. What do you got here? I got rotated about the y-axis. They're trying to give you this rotation thing, so they're trying to go high-tech on you guys, trying to make you visualize a bunch of stuff. Welcome to Calc 2. But it's bounded by the curves y equals x squared. What does the y equals x squared look like? It's a nice parabola right here. That goes to the origin there. This is y equals x squared. Y-axis, x-axis. And they said they rotated about the y-axis. If I take this thing and rotate him around the y-axis, what does it look like? It's like a cup. Rotated around the y-axis, right? So you got to think that circular thing. They're trying to get you guys to visualize this stuff. Does this make sense? If I take this and spin him, I'm going to get that little cup thing going down. Does that make sense? What are my bounds though? With x equals 0 and y equals 1. So x equals 0 is down here at the origin. Here's x equals 0. And y equals 1. Y equals 1 is horizontal right here, so that's my top. Y equals 1. So they're going to stop right here at 1. Does that make sense? So this is 1. Trying to make it fancy, but it's just a 1 there. Okay, so there's my tank. I'd had to draw the tank. That's what frustrated a lot of people. Okay, it's full of what? It's full of water. Great. All right, I can do that to it then. All right, so it's full of water. The tank sits on the ground. Find the work done in pumping water out to the top of the tank. How do you pump water out of a tank? What's my formula? Work is equal to what? The sum of the delta force times distance pumped. Does this ring a bell? And what is the formula for delta force? Delta force is equal to what? It is what I call water weight times delta volume, the slice method. Does this ring a bell? All right, so here we go. Look at your units. What are my units on this problem? They even said it somewhere in this thing. All measured in meters. Being meters, what is the number that you have memorized for water weight? 9,800. But if you didn't know that, they're trying to give you a hint. The density is 1,000 kilograms per meter cubed, and the gravitational constant is 9.8 meters per second squared. And how do you get the water weight? You multiply gravity. That pulls that, make you have weight there. Times the mass density there, times 1,000, which gives you 9,800. Just to quiz you guys, let's say this thing was measured in feet. What would my water weight be then? 62.5 pounds per foot cubed. Numbers we have memorized. Welcome to Calculus 2. All right. So, this one's 9,800 times delta volume. What is my delta volume going to be? The delta volume is called the slice. So I'm going to come over here. I'm going to take my y-axis, because remember, work is all about lifting. Make a little delta y cut. And if I make a little cut on this thing and pull this region over because we rotated it, what does it look like? It looks like a little disc, a little cylinder, if you will. Right? It is delta y tall. Now I want to figure out the volume of it. What's the volume of a cylinder or a little disc here? The volume of a disc, delta volume, is going to be pi r squared h, right? It's a cylinder. Pi r squared, the circle, times the height. what is the radius on this guy? It is going to be moving away from the y-axis. It changes. If I put it up here, it would be big. If I put it down here, it would be small. It changes. But I'm moving away from the y-axis. When you move away from the y-axis, what's your variable? You have a radius of x. So this is pi x squared. What's the height of this thing? Delta y. So there it is. There's my change in volume. If I make a little slice, what does that volume little piece look like? That will be, the volume slice is going to be pi x squared delta y. This is my change in force. So work is equal to the sum of the change in force, which is 9,800 times pi x squared delta y. This is your delta force, times the distance you have to pump this thing. They told me they want to pump all this water out to the top of the tank. Where's the top of the tank at? 1. Top of the tank is 1. This is where we're going for, top of the tank. You made this arbitrary cut at a y level somewhere on the y-axis in the middle. What is the distance I have to pump this y level up to 1? What's my distance I have to pump? Top minus bottom, 1 minus y. Does this make sense? Does this ring a bell? Okay, keep going here. Work is equal to, let's turn this into calculus. 9,800 pi is a constant. It gets pulled out front. Summation turns into integration. X squared is a variable times 1 minus y. And what does the dy turn into in terms of calculus? Delta y turns into dy. I got to screw that up. Okay, dy. Does that make sense? I got a problem. What's my problem with this one? I got x's in the middle of my y's. What is the main variable in terms of work problems when you're trying to do pumping? Y, because it's all about lift. Does that make sense? But I got an x in the middle of it. So I got this x squared. I need to get rid of it. Well, wait a minute. Is there an equation that relates this stuff together? What is actually x squared equal to? This is why they gave you the equation, the edge of the tank. X squared is equal to what? Y. So because y equals x squared, I get to replace it. So work is equal to 9,800 pi times the integral of y, replacing it, with 1 minus y dy. Now I've got to have bounds on this thing. What are my bounds on this particular problem? It's dy, so I want the y numbers. We're trying to pump all the water out of the tank. Where is the water in the tank? From where? 0 to 1. Where the water is. If I told you to pump half the water out of the tank, where would you integrate from? Would you remove the top half or the bottom half? Top half. It would be 1/2 to 1 type thing here. Does that make sense? You only integrate the part you want to remove, and it's got to be where the water is. So here comes my integral, but now we can integrate this guy. I can either do this by hand or not. It's okay. You can also do this one on the calculator, because this is really, in terms of grading it, this kind of a problem, this is what they're really after, is setting up this integral. Yes?
The problems we had before, there was some
Yeah.
that had a slant.
Yeah. Well, just like this one. This one has a slant, but they gave me the equation of that slant when they did the rotation.
But there was other problems we had to start with.
Point slope form, you had to come up with the equation of the edge of the tank. Or if I gave you a circle, x squared plus y squared equals r squared. But somehow you've got to come up with the equation of the edge of the tank. Usually it's a line. Occasionally they'll do a circle, but usually it's a line. This one was parabolic shaped, so they gave you the equation of that. So they were awfully nice. Yeah, question? All right. Yes, Richard. Yes, you do. I'm not done yet. You do. It does say find the work done. But I'm telling you, in terms of points, this is the major point right here. All right, now, the final answer is this. Now, I could integrate this thing by hand by distributing the y and y squared. Or, because of this level of problem, I can sit there and just type it in on my calculator. But traditionally, with the pi thing, because it was a circular disk, I'm going to leave the pi in the answer. So this would be 9,800 times the math, number 9, function integrate on the T84 of x times 1 minus x, comma, low bound was 0, comma, upper bound is 1. And I get, and for those people who love fractions, math fraction it down here, what do I get for the answer? I get 4,900 over 3 pi. But here's the deal. Some people got it down to this one, circled this answer, and they lost 2 points. Why?
No units.
No units. This is a work problem. It is a physics problem. All physics problems must have units. What would your units be on this problem? Newton meters, because this is a metric problem, it would be accepted as Newton meters or joules. If it was an English problem with feet and pound, it would have been a foot pound. Question? You got it? Okay. Does that make sense? So the answer is this. We would accept this, or we also, for those people who just love their calculator answers, we would also accept 5,131.268001 joules. Don't forget the joule part. And that is actually me putting the pi on the actual answer. We would have accepted that too. At this point, we're just happy and giving you full credit for it. Welcome, 12 more points on the final exam. Does that make sense? Questions? All right. Occasionally, they were going to give you these problems where they want you to do stuff in steps. Use part A to get part B type thing here. All right? So, look at how this problem was given to you guys. And it's part of this part A, part B connected to each other. And it's amazing. A lot of people got part A right and they screwed up part B because they weren't thinking. Take your time. We got tons of time. You got 3 hours for this exam. Recall that the power series of 1 over 1 plus t, which is the sum as n goes from 0 to infinity, of negative 1 to the n, t to the n is 1 minus t plus t squared minus t cubed, yada, yada, yada. Man, that was awfully nice. They gave you the power series. Usually they make you derive it or have it memorized. This is one that you're supposed to have memorized. It's also the power series representation for this guy. And they tell you the interval of convergence is negative 1 to 1. They want you to figure out a power series expansion for the natural log of 1 plus t. Now think about it. Think the problem. They gave me this dude, and I want this dude, and we're in calculus 2. Don't hurt yourself. I got this dude, and I want this dude. What is the relationship between the natural log of 1 plus t and 1 over 1 plus t? Well, if this is y, then y prime would be 1 over 1 plus t, right? That's the derivative. So to get this dude, I have to integrate the derivative. Think calculus. Does that make sense? But I want a power series. So to do this, I'm going to integrate the power series. N goes from 0 to infinity of negative 1 to the n, t to the n dt. We're doing dt's here. How do you integrate a power series? Well, you just leave the summation alone. Starting it still at 0. Remember our big theorem there. You still start at the same number. Negative 1 to the n is a constant. You're going after the t. What's the integral of t to the n? Integrate. Add 1 over add 1. That'll be t to the n plus 1 over n plus 1, officially plus c. But you will notice that this is the power series for the natural log of 1 plus t. And if I plug in 0, the natural log of 1, this is t equals 0, would be equal to the sum of 0, because if I plug in t as 0, I'm just adding up a bunch of zeros here, plus c. And what is the natural log of 1 equal to? What's the natural log of 1? 0, which tells me c equals 0. You did need to tell them that. Which tells me my power series for this guy, the natural log of 1 plus t, is equal to the sum as n goes from 0 to infinity of negative 1 to the n, t to the n plus 1 over n plus 1. However, this was one way of doing the problem. We would have also accepted the answers. If you didn't like writing out this guy here, put the big or. See the or right there? You could have just integrated the actual terms right now. We were just so happy to give points. We'd take almost anything on this one. So if you don't want the power series, you can integrate the actual series terms right now. This is the integral of 1 minus t plus t squared minus t cubed plus dot 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 dt. So this would have been, what's the integral of 1? T. Minus, what's the integral of t? T squared over 2. Plus, what's the integral of t squared is t cubed over 3. minus integral of t cubed is t to the 4th over 4 plus yada, yada, yada. And we would have also accepted that answer. T minus t squared over 2 plus t cubed over 3 minus t to the 4th over 4 plus yada, yada. Your plus c, you're still c is 0. So we would have taken it either way. Any which way you wanted to give it to us, that's fine. So either one of these guys would have been an appropriate answer. Yes. Yeah, because you understood the relationship between 1 over 1 plus t and the natural log of 1 plus t is that to get the natural log of 1 plus t, I had to integrate 1 over 1 plus t. So that's a calculus concept. But the nice thing is, if you have a power series representation for it, I get to integrate the power series. And we would have taken that integral power series either way, with the summation or with just the terms. It was your choice, which way. But leaving it blank was not an option. Yes? 3 or 4, catch a pattern. We don't 1 or 2 is kind of short. 3, 4. Notice what I did. I used the terms that they gave me, and I continue with that. Anytime you do that, you're actually going to be fine and dandy. Then you got part B over here. Notice it's connected to part A here. Here's the deal. Use the expansion to derive, and you derived in part A to approximate the natural log of 1.1. They want me to figure this thing out, but they did not want you to use your calculator in terms of, okay, natural log 1.1, write out the decimals. Minus 27 points on a 5-point problem. All right, here's the deal. You're supposed to use part A, and you have to show your work. Here we go. The problem, part A, let's write it out like this because it's easier to use this guy. I think you'll see it better. Natural log of 1 plus t is equal to t minus t squared over 2 plus t cubed over 3 minus t to the 4th over 4 plus dot, dot, dot. Does that make sense? But here was the problem that people died on. I want to actually calculate the natural log of 1.1. What does t have to be? I want to find what the natural log of 1.1 is. The formula is the natural log of 1 plus t. What would t have to be? Which one? How much is it? 0.1 or just 0.1. T is 0.1. A lot of people plugged in for t. Guess what number? 1.1 and plugged it into the series, which went off wrong. That was the wrong t number. Your t, and this is the question, is basically if I want to calculate natural log of 1.1 and use my power series of natural log of 1 plus t, what number do I have to plug in for t? It's 0.1, because 0.1 plus 1 is your 1.1. Does that make sense? So this would be equal to 0.1 minus 0.1 squared over 2 plus 0.1 cubed over 3 minus 0.1 to the 4th over 4. You catch a pattern. How many terms do I need to go out to? Well, here's the deal. What kind of error they want? 10 to the negative 4. What exactly is 10 to the negative 4? That is 0.000. It's 4 decimal places to the left. That'll be 0.0001, right? So you had to take it out enough terms, but if I take 0.1 and raise them to the 4th power, that's 0.1 times 0.1 times 0.1. That right there is already less than that error. Does that make sense? So I'm already within my tolerance if I go out to 4 terms. Does that make sense? So I'm just checking to make sure once I go out to a certain number of terms, I'm already less than this is what's being added and subtracted. This is alternating series. I could actually do the alternating series test type thing on to figure out how many terms, but don't care about that. All I want to do is make sure that I'm less than this number right here when I plug it in. So now it's literally a calculator problem, not the plugging in natural log of 1.1. That was cheating and people failed for that. But it's this. 0.1 minus 0.1 squared divided by 2 plus 0.1 cubed divided by 3 minus 0.1 to the 4th divided by 4. I got the number 0.0953083 repeating. Does that make sense? And that was the answer that we would have accepted. If you took it out to a few more terms, we didn't actually tell you how many terms to take it out to. Anything closer than that, that's fine. But understand on this problem, it was all about this work right here. You had to show what the t-value was, and you had to show you plugging it in either into this form or this form. And just to double check, I mean, I'm not stupid, you should always double check your answer. What are we trying to calculate? Oh yeah, the natural log of 1.1. Let's see if I'm actually close. Oh yeah, I'm pretty close. And notice that my answer is 0.000. The error starts out here at the fifth decimal times 10 to the fifth type thing here. Does that make sense? Negative fifth. So, I'm sorry, let me see if I can see that. So it's very, very close, and my error is clearly within the 0.0001 part. I got it correct right to this decimal. Does that make sense? All right, one more. All right, remember your Simpson's rule and trapezoidal rule and all the error estimates on those things? Lots of memorization. And please do not let this be the only exam you guys do. We've done so much more in this class. You need to look back at other exams just for the different kind of wording they're going to do and the different kinds of problems and to remind you of formulas you're supposed to know. What about this one? This one says this. Let me blow it up. You guys can see in the back there. It says this. The error estimate with the Simpson's rule used to approximate the integral from a to b of f of x dx is given by the error for Simpson's rule is less than or equal to k times b minus a raised to the fifth divided by 180 n to the fourth. What was the Simpson's rule for, what was the error formula for the trapezoidal rule? It was k less than or equal to k times b minus a what? Cubed over 12n squared. And what was the the midpoint rule error formula? K times b minus a cubed over 24n squared. Remember your forms, things you were supposed to have memorized. But they were nice enough to give this thing to you. They didn't have to. You were supposed to memorize everything. Calculus too. All right, but the Simpson's rule where n has to be even. Remember that. Simpson's rule, n always had to be even to do Simpson's rule. And the number of subintervals for an upper bound of k to the fourth, k fourth derivative of f on the interval between a and b. In other words, what exactly is k? It's the upper bound for the fourth derivative. For the trapezoidal rule and midpoint rule, it was the upper bound on the second derivative, was your k value on the interval from a to b. Remind you of what we did way back when we did Simpson's rule here. All right, here comes the question. So this is all formula. They're just trying to remind you of the old formula here. If Simpson's rule within subintervals is used to approximate the integral from 1 to 2 of 1 over x dx, dx over x, you do not need this. Okay. How large n must be to guarantee an accuracy to be within 10 to the negative 8th? Recall, n must be even. Basically, they want to know what the error is going to be on this particular formula. Basically, with an error of, what is it? With an error, this is my error right here, of this number, how many intervals do I need to be? Well, here's my formula, but the first thing you got to do is you got to find k. So what is my function that I'm trying to integrate here? What's the function I'm trying to integrate? It's 1 over x, also known as x to the negative 1. The k value, just to remind yourself, on Simpson's rule, the k value is the maximum value on your interval of the fourth derivative. Okay? So I need to take the fourth derivative of this guy. Well, don't worry, this thing's not hard to take derivative of. What's the derivative of x to the negative 1? Negative 1, x to the negative 2. What's your second derivative? 2x to the negative 3. What's your third derivative? Negative 6x to the negative 4. What is your fourth derivative? 24x to the negative 5. Or 24 over x to the fifth. This is the guy that I need, my fourth derivative down here. But remember my bounds. My bounds are between what? 1 and 2. So I'm looking on the interval between 1 and 2. Now, just to give you an idea of what you're looking for, you're trying to find the k value. It's the maximum value or the maximum y-coordinate of the fourth derivative. If I graph this thing between 1 and 2, plug it in. 24 divided by 1 to the fifth. 1 to the fifth is 1. 24 divided by 1 is 24. That would be up here. 2. 2 to the fifth is what? 2 times 2 times 2 times 2 times 2. How many? What is that? 32. This will be 24 over 32. 24 over 32. It's some kind of a fraction here. And if you graph this guy, it looks like this. All right. What is the K value? What is the maximum value, which is the maximum distance away from the x-axis within this region? What's the largest y-coordinate that you got here? K value is 24. This is what we were looking for in this problem to get partial credit. You had to tell me first what the K value is, because that's what you need for this formula. All right. In this problem, I remind you, A is equal to 1, B is equal to 2. The error formula for the Simpson's rule is less than or equal to K times B minus A to the 5th over 180 n to the 4th. This error for Simpson's rule is less than or equal to K. What is your K value again? 24. What is your B value? 2 minus what is your A value? 1 raised to the 5th divided by 180 n to the 4th. The goal is to remember you're supposed to find n. How large an n do we need? Does this ring a bell? This is your error. You will want this error to be less than or equal to what number? 10 to the negative 8th. This is the error that this thing has to be bounded by. Does that make sense? All right, let's crunch some numbers here. Don't hurt yourselves. What's 2 minus 1 raised to the 5th power times 24. So this is 24 over 180. Yeah, I can clean that up later. N to the 4th. I don't want to mess you guys up in showing my algebra on this thing. And that's less than or equal to 10 to the negative 8th power. I am going to solve for n. How am I going to solve for n? I'm going to multiply both sides by 180 n to the 4th. That will cancel over here on the left. Does that make sense? That would give you 24 is less than or equal to 10 to the negative 8 times 180 n to the 4th. I got to get the n to the 4th by himself first. Does that make sense? How do I get this n to the 4th by himself? I'm going to divide by 10 to the negative 8 times 180. What I do to one side, I do to the other. They're both positive, so no worries, no sign changes or anything. This cancels here, leaving me with n to the 4th is greater than or equal to, as I read it from the left here, from the right to the left, of this number here. And I'm going to use my calculator. We are calculator prone on this particular part of the test. Don't forget parentheses right in your denominator. 24 divided by parentheses 10 raised to the negative 8 times 180. A very large number. What do I get here? Let's see here. How many 3's do I get? 1, 3, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.33. Does that make sense? What kills off that 4th power? 4th root. So I'm going to take the 4th root of both sides, but this is a calculator. If you don't remember where your root button is, you would, in other words, take this number and raise them to the what power? 1/4 power. Welcome to calculus. 1/4, make radicals, fractional exponents. And what number do I get? I got n has to be greater than or equal to 60.42750795, whatever. But they want me to solve for n, and this is Simpson's rule. So let me blow this up so you guys can see this thing. N's got to be bigger than 60.4. You always, when you're looking for sample sizes for the Riemann sums, you can never have enough samples. You always round them up. So if I round 60.4 up, what number do I get? 61, and that's the wrong answer because Simpson's rule has to be what? Even. So I've got to round up to be even because of Simpson's rule. So what exactly my n value should be? Keep rounding up till you get to an even number. The actual answer is 62. Does that make sense? Did that lead you guys anywhere? I got a question for you guys before we leave this fine institution and you guys do some more studying here. How did you find this free response part of the test? How did you find this whole exam, by the way? Was it that bad? That's because I was doing it, number one, helps you out. But my question to you is this. What do you think the class average on this particular exam was?
Average over all my previous tests combined.
62 is what it was. 62. You know why? Because some students got to some of these problems like this first one right here, and they got frustrated because they didn't know what to do, and they left it, what? Blank. When you leave questions blank, those are huge point totals you're missing out on. You know something, always write it down. Don't let this be the only exam you guys study. I'll see you guys, what time? 7:30 in the morning in College Health and Human Services, room 155. See you guys then.